Cool. Sorry, I got mind controlled into not noticing it was 6:03 by the fact that I came here to set up the laptop, and video mute was on. I didn't know that. Oh, do you have a question? Or are you vibing? Is there a QMD? Yeah. So I think I didn't push an update by accident. So I'm also not sure how old these slides are because I've been working on them. That's kind of sketchy, but so I think it's session 7 tonight. Yeah, this looks fine, right?
Yep.
I thought I had Discord open. Did I make that up? Okay, I'll put this link in Discord in the fullness of time. Also, I finished prepping the entire semester over break, and I clearly just didn't publish it. So I had this like waking nightmare on the drive down here that's like, what did I publish? But anyways, it's all happily sitting on a physical hard drive up in Portland. And so hopefully, I distinctly remember finishing the dimensionality reduction things well before break. So wait, is this our class? Yeah, here we go. Cool. And then the other place to find these, we'll pull the curtain back a little bit. One thing I don't like is, for whatever reason, when the QMD files are published on like the open internet, they lose the heading. And I didn't know this until I couldn't figure out why none of you were using the embed resources thing, which goes in the heading. And so you can find them here. And so how do these things correspond to each other? Let's do side by side. Okay, so, oh, that's hard to see. Okay. So if I mouse over this, it's very small and it's at the bottom. But that says data 505/lecture/source. This one's called Voltron because I put 3 different lectures together to make it. But usually they're called section or session. So this is session 6. Now if we scroll down, we have session 7. That relative path, 505 lecture session, corresponds to an HTML file. And these are those HTML files. So if I were to download this file, which is going to take forever for some reason, is the internet slow? It got there. How do I download this? Oh, my computer's slow. Okay. So this session 7 is the same session 7 that we are looking at when I click on this thing. And what is the difference? When I just download this, I don't have all of the styling presets on my computer. Remember when I was like dragging HTML files around and the styling was changing? So this doesn't have any of the styling. That said, this looks kind of nice, right? Like maybe this is an okay way to take notes. It gets a little sketchy, right? Because here's a column thing, right? But if I make that full screen again, then it's fine. So this is what we're going to look at tonight in one format. I had to upload this to YouTube. Okay, so we go back from there, because that's not actually what we were trying to do. This is lecture. These HTML files are generated from QMD files. And where do those QMD files live? They live in something called source. How do you know this? Well, if you mouse over this thing right here, it's the exact same location. So this says lecture/voltron7.html. Yeah, I feel weird saying Voltron. This one says lecture session6.html, and this one says lecture source section6.qmd. So we just look for a source in here. There's a bunch of nonsense, but here are all of the QMD files. I have some of the Python ones in here. And what is the nice thing about this QMD file? Well, first of all, where this is hosted on GitHub, it comes with syntax highlighting, which is one of my favorite things. Oh, these things are different colors. Oh, that's nice. There's line numbers and things of this nature. But it also comes with this header. This is specified in yet another Markdown language, which some of you may know from Data 505. And this has the additional nicety that every time I run a code block, it doesn't have to run again until I change it, because I'm caching and freezing all of the results of every code block. That makes it much, much faster to build this website if you make changes to it. It does not make it faster the first time, it makes it slower the first time. This is relevant for one reason. The homeworks, and I think they're not anymore, they were originally compiled with embed resources. And I think I don't have an example of that anymore. Nope, yeah, it's all gone. But anyways, you can see all of the homeworks here as well. Okay, that's how the website works. You should know how to make websites, you're data scientists, but you don't have to like study web design because you're not web developers. Has this successfully been posted into Discord? Yes, it has. Okay. Thank you for your question. Okay. We stand now at a precipice, an inflection point in machine learning. And this inflection point exists at the difference between supervised and unsupervised learning. And what is the difference? Well, in supervised learning, you know the answer. Or perhaps there is an answer, right? And so as we step past that this week, we're going to be working in sort of something of a slightly different space. To motivate this, when I was working on my doctoral thesis, I used a technique known as specification mining, which is a special form of data mining, where the output is not necessarily a data visualization or a measure of central tendency or something, but it is a specification logic for a program. So this is a form of data mining that was applied to programs. Generally speaking, when you're trying to figure out what a program does, you don't already know. That's why you're running this tool over it, right? So it used a form of unsupervised learning, where we didn't know what the program was going to do. We were evaluating the program to see what it was going to do. And in our interest, we were evaluating to see if it was going to do something unsafe or insecure. And that was all we cared about, right? There were two algorithms that were implemented in Java in 2005, which is a very long time ago, right? And they were k-means clustering and hierarchical clustering, which is what we're learning about next week. So the only machine learning I've ever done was very, very specifically these two algorithms for unsupervised learning. Separately, and this is a fun anecdote, because this was back in the days when people first started running machine learning workloads on graphics processing units in their computers, I was given strict orders to not under any circumstances say what I was doing was machine learning, because it wasn't neural networks, right? So past sort of unsupervised learning algorithms, there's this thing called neural networks, and that is the last day of class, right? So there's these, machine learning means different things to different people. When I was working on my doctoral thesis, you got in trouble if you referred to something other than neural networks as machine learning. These sort of intervening weeks, we're going to learn about these heuristic algorithms that I had been calling optimization theory. So they're like constrained optimization logistics, things of this nature. And the stuff we learned before now, which is also machine learning, we're often calling that econometrics or multivariable statistics, right? And now all of them are done by scikit-learn and therefore are machine learning by definition. But that's relatively recent. Okay, review of the midterm. Let's see, this is probably the most important thing first. I misnumbered my weeks. Okay, so how did I do this? And Kale pointed this out. Thank you, Kale. Are they still misnumbered?
They fixed that,
They're fixed now. Okay, so counting, not my strong suit, right? I do much better with variables. What this means is that I don't recall what the original announced dates for this were, but I believe I had us giving the final after the last day of class. And that's bad, right? Because you might be going somewhere or something. And I could say, none of you said anything about this, but in fact, Gail did, so someone did say something about it, right? So we can't have class after the last day of class, which means the final presentations have to be on 21 April. If you count up your weeks, you'll notice that I have not stolen any weeks from you. That is exactly the contractually obligated 14 weeks of 4 hours, and if you multiply that together, you get the right number of contact hours to get 4 credit hours, right? So what has changed on this website is I had previously announced a deadline for Model 2, which I did not want to change because it was announced. That said, usually Model 2 is due much before this. In theory, you know everything to do Model 2 right now, so you're not waiting on lecture. So in theory, I could have had you present that today, right? That seemed unreasonable, and I also wanted to give you some time off over break, which I hope you all took advantage of, right? So anyways, now Model 2 is backed right up against the final being on the 21st. And what is the difference between Model 2 and the final? Well, there were 3 models in this class, and you were only meant to talk about one of them, and that's the final model. So my expectation is you will turn in the same thing for Model 2, or the same type of product, not the exact same code, as you turned in for Model 1. As far as I could tell, I looked at all of the Model 1s. They all seemed like the formatting worked well. It ran well on my computer. All of the bugs I found are related to me, like having the wrong version of R in some installations and things like that. So that's good for me to find out. So for Model 2, we'll be asked for much of the same thing. Model 2 is posted. And if we finish lecture early today, you'll get some time to talk to your groups about Model 2. And if you don't, you don't. And that's sort of baked in the way it works. The final presentations are also something you want to be working on because you don't want to work on them all in 1 week, right? So pace yourself accordingly. You are all adults and you are all making good decisions. So divide this work up however you want. In the past, I have appreciated having multiple different concurrent assignments out because I can go between them when I get stuck. So perhaps take advantage of that type of sequencing or not. But the final presentation is specifically worthwhile because in addition to having all of the sort of machine learning objectives in it, it also has the communications and presentation and oral presentation learning objectives that we would like students progressing through a master's program to get. I refer sometimes to my master's program, and in fact, part of getting a master's degree is you have to stand in front of a bunch of people that don't think you did a good job with your research, and you have to answer their questions. And if you do a good enough job, they give you a master's degree, and if you do a bad enough job, they wait 3 months and then give you the master's degree anyways, right? And so that's sort of the way the sausage is made, right? So I wanted to give you that update on timing because I think this is a change from April 21. Okay. I also wanted to review the midterm. I don't have prepared notes or remarks on this, and I didn't think it would be helpful to have them. I received an alarming number of questions, and I'm going to describe why I found it alarming, of the form, I do not understand what you want on X. And I'm a little skeptical of that because of the students that started on Monday, which we'll refer to as the try-hard students, right? They were doing better than everyone else. All of their questions were about how to submit on GitHub Classroom. And what does this mean to me? That means that the most confusing thing was how to submit on GitHub Classroom, right? Because all of the students that started early, and also, by the way, half of the perfect scores were those students, did not have any questions about the contents of the midterm, but only had questions about the submission instructions. And I am completely willing to accept that the submission instructions were unclear, not the least because I sent out an email that referred to GitHub Classroom as Google Classroom. And it is true that in my brain I do not perceive any differences between any words that start with G, right? But you may perceive this difference, right? Did you know that there's a color called green that is not actually the same as GitHub? I was unaware of this, right? I had to learn that from a computational linguistics framework. One of the reasons I think the instructions were relatively clear is because, in my view, I posted the absolute closest thing I can post to the answer key to the midterm 2 weeks before I gave you the midterm, and then spent 4 hours in class expecting you to look at that answer key. And that answer key is called solution, and it is right here. And it is, in fact, for a different data set, right? But here is an example of the, let's see, the most common mistake on the midterm was around 50% of submitted midterms did not use weights for some reason. Weights were the subject of 2 lecture hours, 2 weeks prior towards releasing the midterm. They were discussed that week, and then they were assigned on the practice midterm, which we did in class, and I walked around and asked you if you had any questions while this was happening. On classification techniques, there are exactly 3 bullet points, one of which says use model weights. And if you did not know how to use model weights, what you can do is you can press this button right here and then turn in my code for perfect score, right? And 50% roughly, I don't remember exactly, of students submitted midterms that did not do this, which I found surprising. And I do not think that that is confusion with my instructions. I am unwilling to accept that. I am willing to accept feedback of other forms. But that led me to be confused about what we do and don't know about machine learning. My impression is that actually you all understand machine learning pretty well, and probably what we don't know how to do is read documentation and look at other people's code and apply it to the workloads we're currently working on. And we're going to practice that by continuing to do the modeling assignments, which are the best way to do this. So I think going forward, the modeling assignments are a good way to do this. If you have questions about the midterm, I believe I distributed to all of you a feature vector. It was a series of 20 Booleans that assessed how well you did, I hope objectively. I really like true-false grading because I think it can be more objective, and I really dislike it because it's very easy to get a 0, right? So that was somewhat stressful to me. But that feature vector was derived from something that I also felt like I gave you before I gave you the midterm assignment, which it is the bullet points on the rubric that was distributed for the practice midterm that we spent 4 hours of class time working on. This rubric, by my accounting, had 17 bullet points, and the remaining 3 bullet points were used GitHub Classroom, and then you turned in code that actually could compile and render. I had a small number of cases where I think probably what happened is something was uploaded to GitHub and then the text was edited in some way. That happens from time to time, and that happens to me all the time, so I'm used to that mistake, right? When you are submitting something to your manager or a hiring manager, if you're going up for interviews, right, do take the extra step to whatever you have uploaded to some website, download it, and make sure it runs the way you expect. I hope you all learned something from that process. I sort of gave you I don't know if it's like a relatively difficult way to turn this in or something. I talked to Professor Rembold, who I guess is also requiring GitHub Classroom, but you are not all necessarily in that class. And we do think that this way of moving information around is close to what you will see in industry. All of the work I did in industry, we weren't allowed to use GitHub for Defense Department reasons. But my impression is that if you get a job at New Relic writing Python in Portland, they use GitHub for everything because you can see their projects on GitHub. Get a job at Rivos, get a job somewhere, right? So I expect GitHub to be recurring in your careers, whichever way you go. Increasingly, GitHub is being used by people like journalists who don't necessarily write code and just need a place to store files, right? So I think that's going to be coming up a lot. Okay, that's my unrelated diatribe on the midterm. It did not look like anyone attempted to do something and failed it, but it did look like we did not take advantage of all of the resources at our disposal to produce high-quality documentation, and that's my takeaway. Okay, what did I press? Does anyone have any questions about anything? Do you all know how to find files on the website? And I did not post the QMD today. Thank you. And I showed you how to find it, right? It is good to ask questions if you can't find things and you're not sure. Okay, let's reduce some dimensions. Modeling project 2 I think is over real data. I was looking at it, it looked real. Professor, I guess all of the data is real, right? Like, it's like different real data. The ISLR data sets like don't feel real to me. The miles per gallon data set is like famous, like everyone uses it all the time, but like, I don't know if the numbers are real. Like, I don't know if anyone checked, right? Like, I don't know how many cylinders a car has. Do any of you know how cars work? That's like a dying art, right? Like, I think like people used to know how to change their own oil, and now cars don't even have oil in them. But they don't. They're all electric now, right? 100% of cars are electric. Okay. So I don't know what churn is, but statistically speaking, some large percentage of you are going to end up working in the banking sector at some point in your life, right? And I have thus far avoided that, but like I can see it's coming, right? Like that could very well happen to me at any point in time, right? Like you never know. And so there's something called churn. Does anyone know what churn is? What's churn?
It's churn is like referring to staffing, right? Like people leaving, or are you meaning like customers leaving?
I don't know. We'll find out when we look at the data set, right? Okay. So something's leaving, we think, right?
Yeah.
Okay. So perhaps I run a bank. We'll call it the Bank of Calvin. It's named after the Protestant theologian, no relation. And this bank offers like low APR starter interest loan financial services, right? And it really gets people in the door, right? And then some of them leave when they find out that Goldman Sachs has a high yield savings account that's backed by the largest bank in the universe, right? And so you're like, it's hard to compete with Goldman Sachs. They have more money than God, right? And so at the Bank of Calvin, where I work as a financial engineer, I have to somehow entice people to not pull their gigantic piles of money out of my accounts and put them into someone else's accounts, where those people can then put them all into cryptocurrency, lose them, and then get bailed out by the federal government, right? So in order to do this, you're allowed to predict 5 features, and I'm going to evaluate your models based on the area under the curve. We'll leave time at the end to get started, probably. You notice how it says there's 71 slides down here? That's a little stressful. Okay, so I think that's all of our announcements. Welcome back. I feel like I haven't seen you forever. I didn't realize that I was going to not see you and then there was going to be spring break. And now I've forgotten what all of you look like. So I don't know who any of you are. This is data 505, right? What are we learning in this class? No, we already talked about that today. We talked about machine learning for like 5 minutes at the beginning, right? There's supervised learning, unsupervised learning, neural networks. Do you remember all of this? Okay, take better notes. Stop shaking your head. Dimensionality reduction and principal component analysis are, to me, conceptually linked in the following way. When I see a data frame, I perceive it as an n-dimensional object, where there are measurements in each of the dimensions that corresponds to a column. Now, we usually don't think of true or Honda as measurements in some dimension, but we have to some degree demonstrated that we can put all these words on some chart and show that they are correlated with different sentiment or something like that, right? So really all the things inside of our data frame we can convert to just being some number or some direction in some higher dimensional space, perhaps a 4,000 dimensional space, right? So many, many dimensions, right? Or perhaps, a 6-dimensional space, which is almost as hard to imagine, but much easier to look at on your screen, right? So as we think about this, we think, by golly, I sure would like this to exist in 3 dimensions, because then I can graph it as a 3D chart in Plotly and use colors as the 4th dimension and visualize it directly, right? So I'm sort of always trying to get down to 4 dimensions, and you don't have to believe me because I just gave a modeling project where there's only 5 dimensions allowed, right? That's pretty manageable, right? And so dimensionality reduction is this good thing we can do to make data more understandable, right? And that raises the question, how do you do the good thing, right? And so principal component analysis is the technique by which we achieve the good outcome being reducing dimensions. And so let's just look at this word, right? Principal component analysis. So there is probably going to be something that is big or primary or foundational, right? And that is the principal component. Is there some dimension that is dominating the other dimensions? Is there some way of combining the other dimensions that tells us something? On the miles per gallon data set, for example, I think if you were predicting miles per gallon, really, I think you probably just wanted to take the product of a series of different things, like the number of cylinders times the size of the cylinder is very close to the miles per gallon, something like this, right? So we don't actually, when we're visualizing the miles per gallon of some vehicle, need to look at the numbers of cylinders and the size of the cylinders, right? We can just look at engine size, or perhaps we can look at engine weight, or perhaps we can look at engine weight divided by vehicle weight, or something of this nature, right? So there are such things as taking linear combinations over these, but many times these measurements we take are measuring something underlying in the physical world or some mathematical property, but there's something real that we can't perceive directly, but we can derive from our data set as a whole. And so that is what the principal component is. We are trying to find the truth about something regardless of how it exists or persists or is discoverable within our data frame or data set or whatever we have, right? It is linear. So an example of something that is linear is multiplying two things together, right? Generally speaking, when we multiply, most commonly when I was in 8th grade, we multiplied m times x when we were trying to plot a line, and a larger m value corresponded to a steeper line. It has applications in exploratory data analysis, which you have all, I believe, done in Data 501, visualization, which you have done in Data 502, and data pre-processing, which you have done in Data 503. So have you seen principal component analysis before? Has this come up? What class did you see it in?
Well, actually, I guess it was an undergrad class.
Was it Math 280?
Yeah.
Okay. Study your linear algebra, folks. Okay. So you all had the uncommon misfortune of listening to me talking about dimensions. One of my favorite things to talk about, by the way. I love thinking about dimensions. I tried to think about something in 6 dimensions the other day, and my head still hurts. I don't even know why I tried to do that. It was a completely useless thing to think about whatever it was, and now I don't remember what it was because I tried to think about it in 6 dimensions and couldn't form memories, right? So anyways, I was talking about dimensions there for a while. A lot of people really like things where there's 2 dimensions, and don't take my word for it. Ask Sonic the Hedgehog, who is much more popular in 2 dimensions before going to 3 dimensions, right? Any of you seen the Sonic the Hedgehog movies? I hear Jim Carrey's in them. Actual existing person, Jim Carrey. Would not have thought that person was real. And so things often exist in 2 or 3 dimensions if we want to reason about them. I think about Rubik's Cubes a lot, and I think about crossword puzzles a lot, and that's the 2- and 3-dimensional version of something. Because as we all know, colors and words are the exact same thing. They're just the description of some feature in some dimension, right? So I have my data frame. Perhaps it's the miles per gallon data frame. Perhaps it's the bank turn data frame. Perhaps it's the Pinot data frame. And I can think of that data frame as being measurements in some higher dimensional space, right? And I really, really want it to be in some slightly lower dimensional space, or perhaps some much lower dimensional space. Well, in order to do that, I'm going to need to have some transformation, or probably some function, most likely, that relates something in a higher dimensional space to something in the lower dimensional space. And so that is going to be the linear transformation. It is going to go onto a new coordinate system. I think of the new coordinate system as the lower dimensional space, right? And that lower dimensional space is going to have different directions in it, but perhaps not as many different directions. And whenever we have dimensions, the dimensions are exactly perpendicular to each other, so that's 90 degrees from each other, and they are independent. A change in one dimension does not affect changes in the other dimension. This is probably going to be a slightly lossy process, right? We are probably going to lose some amount of information. Do you have a Rubik's? It's a speed cube, too.
Yeah.
Jacob has a speed cube, which is not good for my distraction, because it's like in my frame of view. No, it's fine, it's fine. I don't deserve rights, I'm a professor. And so oftentimes there is some dominating feature that contributes to something. I am most accustomed to seeing this in political science, where basically if you want to predict anything about a congressional district, you look up a little bit of demographic data and a little bit of income data, and it doesn't matter if people have lived there for 400 or 15 years, right? Because either they watch Fox News or MSNBC, and that is the only thing that matters, right? And you can also do this relatively easily with things like predicting life expectancy. Like, it's very difficult to predict the life expectancy of an individual, but if you know their zip code and their income, you can get very, very close. And if that's not intensely demoralizing, I don't know what to tell you. Unfortunately, I found about principal component analysis at some point in my life and instantly became a communist, right? So you have to be very careful when you look at this stuff. This is a linear transform, and I'm going to give you an example of a linear transform. There has been a recurring topic of discussion today. Some of you may have noticed that I have mentioned data 505 a few times. We can actually view data 505 as a linear combination of things, right? You probably have all realized that I made these slides before sending you out a feature vector describing how well you did on the midterm, right? It turns out the principal components of that midterm are, did you read the second bullet point of the third prompt? And do you know what a root mean square error is, which none of us do, but some of us were closer than others. So pat yourself on the back if you got points for that one. It's the square of the, never, okay. So I think I perceive the world in terms of linear combinations. And just let me give you a simple example. For some reason, like 2 years ago, I turned a certain age and instantly only started doing cardio. I've talked about this a few times. And while I'm doing cardio, for some reason, the only form of cardio I do is running. And I think, I don't know exactly how this works because I was never like a real athlete, right? But I think there's something where, like, if you run over a certain speed, you experience some sort of like physiological failure and can no longer run. And if you run under that speed, you're not doing your best and you don't get credit for the workout, right? So like there's this like very narrow range of good enoughness, right? And I'm not like really in touch with my feelings or anything, right? So instead of seeing how my body feels, I look at the numbers on a treadmill and it tells me if I'm doing a good job or not, right? Because we invented computers so we don't have to feel our own feelings, right? So at any given time, I perceive my sort of accuracy in achieving my workout goals as a linear combination of the various speeds I've punched into the treadmill while feeling like I am close to achieving physiological failure, but not necessarily getting there yet. So today, for example, I ran at a certain pace for what I do. I ran at 6 miles an hour for 3 minutes, and then I ran at 8 miles an hour for 15 minutes, and then I ran at 6 miles an hour for 2 minutes, right? And I could take an integral, right, which is like very hard to do while you're hypoxic because I wasn't breathing enough, right? But really, how many miles I'd ran was a linear combination of how many minutes I'd ran at each different speed, right? And so I really was like sitting there, not really completely present mentally, right? Thinking about linear combinations, and it was, it was a pleasant experience. So I hope you can all experience that. I was driving down here, and I don't know if you've all noticed this, but Oregonians cannot drive the speed limit while it's raining, right? So I took a linear combination, and I was predicting how many minutes it would rain, which would affect when I would arrive at this campus, right? And unfortunately, adversely affected my ability to get a hummus plate, which I was really looking forward to, right? So these linear combinations directly affect my life. I live at a certain location. I'm teaching at a certain location right now that is on 200 State Street, right? Where I live does not have an address. Don't look it up. So that street address is very interesting to me as a linear combination because I do perceive that as a linear combination, but State Street is not a number. It is a mysterious other type of thing, perhaps words, right? But those words correspond to some location. So I could take a principal component analysis, perhaps over street addresses, and I could turn them into Geographic Information System, GIS data, right? Presumably that's possible to do. Did you do GIS data in any of your prior classes, right? So we can turn numbers into GIS data, right? And now my personal favorite, some of you have known that I have a part-time job as a member of the faculty at a small liberal arts college that I do in between my YouTubing career, right? And so I think a lot about course numbers, right? And I think way too much about course numbers. And this may come as a shock to you, but if the only thing you do for your entire career is teach 5 courses a year, you become extremely opinionated about course numbers very quickly. And in order to start teaching course numbers, you have to do a doctoral defense where you have to successfully argue with people smarter than you for 4 hours, right? So what all of us do as faculty all day is we argue about course numbers, right? And this is great fun. This is what we do instead of teaching, right? So here's an example. We are in data 505, which I view as a combination of the categorical prefix data. One of the trees we were barking up here a while ago, before we realized we actually didn't want to know the results, is we were going to plot and see which prefixes were the closest together. And it was really, really unpopular that math is probably closer to both computer science and data science than they are to each other, because the math department is not in the computer science and data science department, right? And so we realized we didn't really want to figure that out, right? And so then we stopped looking at this. But I made the case that philosophy is very close to computer science because they're both using Boolean logic, right? Everyone hated that. Absolutely everyone hated that. And then I said computer science should be categorized as a language class because we study programming languages, and everyone hated that too, right? And then the poor physicists were trying to figure out why they're a STEM field and they weren't close to any of the other STEM fields. And I was like, well, you don't study either languages or calculus, right? And they're like, well, we do calculus. And I was like, it's approximate, right? Any physicists in here? Do you go to calculus? No? Okay. Actually, no, this is a worthwhile, we should stop here. Turn to your neighbor and discuss what you think the 3 closest majors at Willamette, and if you're not from Willamette, you don't know them, just speculate, right? We have the same majors as every other college. And think if they are close in the same dimension, right? So I gave the example of philosophy, which is close because it's logic, linguistics, which is close because it's languages, and mathematics, which is close because it is computer science. They're the same thing, right? Data science is very interesting, right? Because I think data science is a linear combination of other fields, right? Most likely statistics, mathematics, and computer science. So discuss this briefly with your colleagues, and I'm going to go around and look at you and try and remember your names, because I need to do that after break. Okay, get cracking.
PPLE, history, international relations. And I think it would be international relations combined into PPLE is basically our almost well nature. I would ask you 3 measures that would be doesn't have to be
At least he's here. I think how much we I messed it up. I said, well, but I wasn't.
history would just be a shared competition.
It wasn't even a major right away.
It would be like, I think it's more
Right, because I didn't like my husband. But I think it just looked very, very
from both of them because it's modern. And it's also I think I want to replace PPLE with I think philosophy, international relations, and history. Philosophy plus history is like kind of logic slash how we reason and that it has with how we that's our people. That's what our politics is.
I didn't have this
I think it's less in the sense of more of like just topics. Like if you're talking every topic in computer science, that would be from cybersecurity to I'm blanking out. What do you call it? Optimization, aka machine learning now. Discussion based. Not major sciences currently, but probably in the foreseeable
This
future.
is true. I just remember having
Statistics, what do you call it? Not math, data science, and
the thing is,
industrial engineering.
because it's been a year since I took it.
Yeah, industrial engineering. They're all heavily statistics based.
Yes.
Industrial engineering will be a subset of data science and statistics. Well, it's really a subset of statistics that overlaps a lot with data science.
There was a little hiccup there.
And data science is just statistics based. So I would say it's not a linear combination, but it slightly veers off because it's specific. Yeah.
Yeah. I'm fine, because like the one USS where I was going to take,
But the environmental, I would say biology actually, biochemistry and environmental. And I would say, and honestly, a little bit, like I would say environmental is biology and chemistry, but it's not directly in them, it's like philosophy slash ethics.
At least it was.
That's what I'm thinking of. That's why I go. I'm thinking about
But I think when we're saying that, yes, law overlaps some topics, but everything overlaps in, like how Calvin was saying, English and computer science and Japanese stuff is all the study of languages. That's why ChatGPT has billions and billions of vectors, because it's actually not so complicated. So much information.
I complained about it today in the class team. The professor was and I was like, so there's a slight I
don't have time to research anymore. But I think Professor Chen
the independent studies
showed
classes.
I
already took it into three.
So
3 of us were 7, which is above the maximum number of electives. But I'm trying to figure out if my 3 credits for like
thinking about information
or
the only English language every connotation.
and I luckily I talked to my advisor, so I was like,
That's why we
you know.
they have a really cool series of calculus. I really enjoy it.
I feel like, especially because it was a required internship, not just like an internship for credit, I feel like it should be
such that they are they
no,
can
not
stand
like
on their toes.
oh, for my program, there's a required internship credit, but I want to do instead of just like, sorry, I'm in a joint degree, so the credits are always like, but you understand, like it's always weird every semester. But instead of taking a second AGSM elective, one of our professors over there offered me an independent study, which I was like, yes, I'd much rather do that than do my class in the summer. But there's like a maximum of 6 credits can be applied to like general elective from independent study series. And I took an internship for credit last summer that was 3, and I need 4 to graduate. So I was like, I really hope those 3 elective credits from internship go towards like a separate like internship credit, not general elective, or else I won't be able to do it. So like, please, I do not want to take a 4th class in the summer. Just let me take a little independent studies. Right. No, you need 3 for the internship, but the AGSM elective for summer, you need 4. Like this upcoming summer, like next semester. The GSM elective? I think you have to take another one, because I'm also in the GSM elective. Because we have to take 4 classes to graduate. As long as this gets approved. If not, I'll just take another class. Oh, okay. Well, not this summer. I don't start this summer.
For the MSCS I did 4 classes in the fall and 4 classes this semester, so I only had classes. I did take some classes. Since for MSCS you have yeah.
That's fine. That's awesome.
Honestly,
we are mixing up. Like I think what we're doing now for that's gonna be the school of arts.
yeah.
Yes, is gonna be
But I think we're getting out of this anyway.
yeah, that's insane. I'm just trying to but so all that is
So you don't do abstract for ASM for that?
No, as of right now, there's no concept for the BS or the MS.
It's literally awesome. I love that.
Yeah.
They have a full supermarket downstairs that's free for all employees, which is awesome. They have a cafeteria that's like we have to pay for it. It's pretty cheap, yeah. Like I packed lunch most of the time, but like sometimes I get food there, and especially on like special days, sometimes I like bagels and like sushi and stuff. So I definitely go for that. And then they have an outdoor, like an entire soccer and training field outside. And then there's like, they also have like all these clubs and like different sports that go on at lunchtime. It's really funny. Otherwise, there's like kitchens and like stuff like that. Like there's like 5 kitchens. But the gym is the big seller. And it has like full shower rooms and stuff.
But did
I think it's 24 hours for HP employees, the gym. And it has a whole cardio section. It has like I think like 4 or 5 actual like squat racks, a free weight rack, and then a bunch of machines and like press. Yeah, they have benches and squat racks and all that. I did. Yeah, and then they also have like the automated machines and everything as well. It's a really nice gym too. Like one of the nicest office gyms I've ever seen. But it's because the location that HP is at used to be, because they lease the location, they don't own it. So they used to lease it to like the manufacturer of all the gym equipment. So it was their sample gym for people to come test equipment. And then when they moved out, they're like, we're just gonna leave it because like it's more expensive to move it than just buy it or like replace it in the new ones. So pretty rad. Also, our office is in the same parking lot as Chipotle, which is pretty rad. I walk over and get Chipotle all the time. That's exactly how mine was. Yeah, I graduated and then went to my car, took off my cap and gown, went and picked up my suitcase and left for my internship. Like really anticlimactic graduation night. I mean, like the Oregon coast, yeah, but they all left right after graduation too. I mean, it's like just an hour and a half from each of them.
Or like I was sure I was like, okay, look, we have this idea, but the site that I want to use has like,
yeah, mine was brutal. I like left and then a semi like moved like all the way there, like destroyed the entire front bumper of my car because it flew off and like went in my car and I drive it home. And so I like showed up to my internship with like a bus in front of me, like good, and I was like, what a day.
And so now I'm like, okay,
That's the one
on the site,
I mean, and then I got there and then it was like,
Generally, this will.
the first day is like you have to be there, but it just feels so like just slow. And I'm like, it is, yeah, like the whole first day is like you're in a room, like a packed room, all the interns, and like one IT guy like running around trying to get everything set up. And it's like 95% undergrad interns, so you'll sit there and they'll be like, what are you? And you'll be like, I'm in grad school, and they'll be like, like, I had that same experience on repeat all day, and I was like, all right, cool. Yeah. I've always just been like straight grad school. I guess you can still say like, oh, I'm like senior type of thing, but. I graduated in 2023.
I came to and then I would come.
mine is something like set up his screen.
I think there were like 7 interns and there were 6 grad school interns. 2 of which were PhD students.
There's like 8 people having a degree.
It's so good because then you can like be like just having to to his platform.
No, actually, that's like if you get a return offer and you say like, oh, I'll start, because I think their return, so they only offer you to start at HP 4 days a year. Like they have them in quarters, like they don't like to just have people start in quarters, because it's like, yeah, like whatever, tax purposes, and also like if they're gonna do reorgs, that's when they do it. So they want people to join in when they're doing reorgs and stuff. But one of their days is so you'll literally have like a break in a couple weeks, and then you can go back, or you can go back to catering. Oh, so you could start in January. Yeah, see, they would eat that up. They hated the fact that it's like,
I got out of like,
and I was like, yes, I don't graduate until like next August. And they're like,
I did have to help my friends, I'm sorry. But I was thinking the sacrifice, so I sat on the couch next to them while they were going. So I would
Like,
They called me about that.
interesting.
I was going to
in a ball on the floor.
because of that, they were like, oh, you qualify. I didn't get it, so there's that.
That's really interesting. I definitely know people people that were hired like right off the bat.
For mechanics. Oh.
Yeah, I mean, I think if you said like, oh, but I can start this date, they're not going to say no. Like, I think they probably put it there for like restriction purposes, but yeah, they're gonna. And I'm one fair. I won best intern. I got free. Actually, try to win best intern because you get like $300 in free stuff. Yeah. Got a new like desk mic, a new like headset with a mic, printer, a shitload of like HP like gear. Yeah. They give you a laptop for free just for working there though. No, not until you go back to work. You have to return it as an intern. I mean, for the time you're working there, you can. Oh yeah. Oh yeah, of course. But it's still nice that like if you're just like, yeah, this one's old, you get a new one. They're like, yeah, can you do this?
So
The fair thing is that like laptops in the summer, the IT guy didn't realize that I was like the intern return that thing, so he just left it in the file and it for like months. Like just literally a stack of like laptops. And all these people in like departments were freaking out because there was like 50 grand of unaccounted like laptops like missing. And so all the interns were all these emails being like, you need to return your laptop. And they're like, we did, like we gave it to you. And then finally in like January, they walked through this guy's office and they're like, look, I think you found all the missing laptops. My boss called me just to tell us he found it. He's like, because they said no interns running wild.
But students had it. But for the majority of professors who are undergrad, they offer it for credit or they have an opportunity because it's like they get
All right, I'm going to summon us back. What I hope has happened is while you were discussing things, you were engaging in something that I like to call metacognition, which is thinking about thinking, right? So something I do a lot is I have a thought, and then I think, wow, that was stupid, right? And then I change my mind, right? Have any of you ever changed your minds? Jacob? I know you haven't. And so something I like to do is, for example, in the space of this class, for example, when I write some code, I think about what it's going to do before I run the code. And then I run the code. And then if I thought wrong, I think about what I thought, right? And if you do that like 6 times, you're the best programmer of all time. Because I have seen production quality software, right? And no one had a single thought while writing that code. I promise you that, right? And so, yeah, can I get like a big whoop whoop for Canvas, right? Everyone loves Canvas, right? It does work, which is amazing, right? Something that the people that get software engineering jobs like to complain a lot about is like the Epic healthcare thing. Have any of you ever like spoken to a nurse and the nurse is like, oh, the computer doesn't work today, right? So like I have never once talked to a nurse who claims the computer is working that day, right? And that's kind of suspicious to me because I know how much money Epic gets paid to make sure those computers work, right? And I'm familiar with Epic because they hire in the Chicago area where I went to undergrad, right? Sorry?
They send me emails.
They send you emails?
Yeah, offering me a job.
Do you have a job?
No.
Then you should accept. Okay. Now, not all of these spaces collapse as evenly. I monitor very, very closely our registration information in this department, and I also monitor it in a few other departments. For example, I make sure I always know how many students are in 100-level chemistry classes, the introductory physics sequence, which here is numbered at 200 level. Why is it numbered at 200 level? It requires calculus. Another 100-level class I monitor carefully, right? And what I have found informally, and I don't have strong metrics for this yet, is that we actually have, in our department at least, 3 bins, which is we have 100 level classes, which can be taken without prerequisites. We have 200 level classes, which can be taken with either 1 or 2 prerequisite. And then we have 500 level classes, which have a different registration code, right? So different students are allowed in that class, regardless of prerequisites or not. And every once in a while, someone says, Calvin, what about the 300 level classes? And we have no true 300 level classes. On average, in the computer science and data science department, it takes fewer semesters to get into a 300 level class than a 200 level class, because all of the 300 level classes are left over 300 level designations from before the 100 level reorganization caused by Data 151, which has built the popularity of this program as well as others, right? What this means is every once in a while you plot 100 levels versus enrollment. And there's no one in the 200 level classes, and there's a gazillion people in the 300 level classes, because a class like Data 351, which is our SQL class at undergraduate level, one of the most valuable undergraduate classes offered at Willamette if you would like to get a job someday, right? You're all taking the grad level, not all of you, many of you are taking the grad level 503 right now. Very, very valuable. It has a prerequisite of either Data 151 or CS 151, which means 200 students a year become eligible to take that class. And it is a 300 level class. This semester I am teaching a class called CS 276, which requires CS 151 and CS 152, a 1-year sequence. On average, 50 students finish CS 152 per year, which means I'm drawing from a pool 1/4 the size of Data 351. So if you look at enrollment, you say, wow, why is this 300 level class 4 times more popular? And well, it's because 4 times as many students can enroll in a 300 level class than a 400 level class, right? So you always want to look at these things. I think about this so often with hotel numbers, because they always add 1 digit when you go up a floor. And very few hotels have exactly 99 rooms on every floor, right? So you are extremely unlikely to get room number 599, and you are quite likely to get room number 501, because many hotels have 5 floors, right? Highly non-independent. I always encourage students to think about this when they're signing up for classes, right? Because you are all quite likely to take a class numbered 599, even though there are not 999 options, or wait, not 900, 99 options, right? You're going to take 599. What does this mean to me? Well, when I break up a course number, I do not break up the letters of the prefix. That isn't meaningful. There is not a strong degree of similarity between computer science and civic communications and media, which both start with C, and chemistry, which starts with C. They are just as different or not different as are any other 2 majors, right? But 2 classes numbered 151 are often quite similar. And often classes with a leading number that is different than 100 are quite similar to each other in some way, which is that they have some prerequisite and somehow attached to their major. And general physics is, I think, one of the most common exceptions to this at the 200 level. So when I decompose, as I do in advising, and I start getting a barrage of advising emails this time of year, which is why I was thinking about this, I encourage students to look at the last 2 digits, the first digit, and the prefix. And oftentimes these are the principal components, even though you are getting many more pieces of information than that when you look at a name. Every once in a while, a student asks me the name of a course, and I have never once thought about that in my life, right? This is Data 505. What do we learn in Data 505? Machine learning. Oh my gosh, we talked about it earlier, remember? Okay, there's supervised learning, there's unsupervised learning, there's neural networks. Okay, do you all need to write that down? I better hear some pencil scratching. What'd you say?
Statistics.
Yes, yes, yes. And which one is that?
Data 505.
Okay, whatever. Okay. Multivariate statistics is the unsupervised learning, right? Okay. So I wanted to help you visualize this, and here is one way to visualize this. So I don't have any idea what this data is, and I think it was randomly generated to look like this. But this is from Wikipedia, which means it's not wrong, okay? And so we have in the center of our screen a very, very nice looking blob, right? just an absolutely all-around great-looking blob. But as we perceive this blob, we notice that it perhaps seems to be spread in a direction that is not perpendicular to either of the two main numbered axes, right? 0, 0 is located around here, right? And so we could have, for example, some sort of y equals x metric directed along, oh, wait, there's 0, 0, directed along sort of this line. But that line is sort of like awkwardly incident with our scatter plot, right? And so if we wanted to conduct some form of principal component analysis over this, it might make the most sense to determine what is causing the spread in this sort of odd dimension that doesn't really line up with our grid, right? And I am thinking of this very strongly as when I am observing miles per gallon, but I am plotting this against cylinders and cylinder size, right? There could be some linear or nonlinear relation. I don't know. You all looked at the data, right? But this is sort of the tree we are barking up today. So why are we doing this? It is easier to think about smaller dimensions. There's one other thing I haven't mentioned yet, and that's noise reduction. I adopted 2 beautiful little house cats this weekend. One of them is named Ursula, which I call her Ursulami. And then there's one that's named Tortia, who I call, no, her name's Tortoise, and I call her Tortabella, because I want to name them after foods, right? Because foods are fun. And they, so the Humane Society was talking to me, and they're like, have you ever had scared cats before? And I was like, I thought that that was the natural state of cats. Apparently these cats have some sort of clinical diagnosis for how scared of things they are. And this is so adorable, right? So they hate noise. I live 200 feet from I-5. That's just like sort of not great for them. But fortunately, through years of loving care, I'm going to win them over and they're not going to be fearful anymore. So don't worry about it. This will have a happy ending. But I have taken some steps in my apartment to minimize noise. And I have done that by changing its linear relationship to I-5, mostly by putting down blinds, which work as a dampening effect, right? When we are using principal component analysis on some data set, there might be something going on 200 feet away from us that is being reflected on the data in some way that we don't care about. Or perhaps we care about it a lot. Perhaps we are looking at a mile per gallon data set and someone went off and passed a Clean Air Act in the middle of our measurement window, right? Which is going to cause things to happen to the data we are looking at. And maybe we care about those things and maybe we don't. In the case of noise, there's just something going on we don't care about, right? There's things that don't matter, or there's just randomization for some reason. Not every engine is equally efficient. Maybe all of the cylinders are not the exact same shape, and that's showing up in our data set, but we don't have a data frame entry telling us what the cylinder shape is, right? We want to iron all of that stuff out, and a helpful way to iron that out is to try and get down to fewer dimensions. So we can start throwing out things that are mostly just noise, right? We want the signal, not the noise. Who loves Nate Silver? Can any Nate Silver appreciators in the audience? We love 538. We love, okay. We're not sure about 538. Okay.
They're all right.
They were really popular in Chicago when I was there because they predicted Obama would win in 2012 after 117% of Chicago voted for Obama. So that was really popular. Don't mess with these political machines when they get going. All right. I have to take a drink. My voice is dying. Okay. In the olden days, there was something called the Netflix Prize. What was the Netflix Prize for? Well, before data science was invented, oh, do you know? Are you thinking? Do you have a great thought you would like to share? Since I've called on you anyways.
Oh, I think I know what it is. I'm going, wait, maybe I don't actually.
So I think it's a 17,000 dimension data set. I don't know for sure. And I believe those 17,000 dimensions come from how many pictures or films or cinemas. I don't know what they're called because they're not on film anymore. And I call them films. And they're not movies because some of them are made by Disney. Shots fired. Okay, so Netflix had this 17,000 dimension data set, right? And it was basically whether people finished watching something they clicked on, right? They released the data set of something called the Netflix Prize. I believe it's still on Kaggle. I don't know if you've ever looked at it. It was a big deal when it came out because it was one of the largest available data sets, and now it's not even close. I don't think it's in the top 20%, right? And one of the problems with Netflix is because data science hadn't been invented yet. They just collected all of this data and they had like sort of no sense of what to do with it, right? But in fact, maybe it doesn't make sense to separately categorize whether someone finishes watching Star Wars Episode 2 and Star Wars Episode 3. Like maybe those things are quite similar, right? Maybe no living human can tell me the difference between those two films, and don't try. I won't listen, right? And maybe it's much more important to know the difference between Alien 1 and Alien 2, because one of them was directed by Ridley Scott, and one of them was directed by my arch nemesis, James Cameron, who does not understand art, right? So they don't have the not understand art vector, really. It's buried in these 17,000 things, right? Because, you know, someone that clicks away from Alien 2 while they're watching it, that's just someone with superb taste who understands Ridley Scott's artistic division and skips forward to Prometheus, right? We can all understand that, right?
Repeat that, but slower.
Okay, so I'm not going to repeat that. No. I saw my first Studio Ghibli? Yeah. I saw Nausicaa in the Valley of the Wind this weekend.
Yes.
And I am so mad I have watched other things, right?
What have you been doing?
I was watching Alien over and over again. That's true, I watched Nosferatu. Yeah. Remember Nosferatu, 1917 is better than 2025. I don't make the rules, right? It's not my fault Hollywood ruined everything, right? So, for some reason, Netflix thinks that Nosferatu and Star Wars Episode 1 are the same type of thing, right? But actually, all of the Star Wars films are identical except Rogue One, which is good by coincidence, probably. And then, okay, anyways, it doesn't always make sense to have a vector for every single one of the films on Netflix, right? And so we think of this as a curse of dimensionality. Why is this a curse? Say I have 17,000 films, and for each one of those films, I have a yes or a no, which is whether you have watched it and liked it or not, whether you have the positive sentiment, right? Well, that means that the possible number of sort of features you can have is 2 to the power of 17,000, which is a large number. Does anyone know how large it is? The answer is very, right? It is very large. Would you say that is larger than the number of Netflix subscribers? Would you say that compared to the number of Netflix subscribers, the number of Netflix subscribers is very, very close to zero? Right. So they essentially had no interesting data in this at all. And the best thing you can do is go in there with their feature vectors and say, you know, we probably want to have like 5 dimensions. And those dimensions are understand that James Cameron doesn't appreciate art. And I think that might be the only one, right? I don't know if you even need anything else, right? You know, there's some people that think Titanic is art. Disappointing, right? It's only the soundtrack. Okay, so as we take more and more features, right, we get closer and closer to a very large number that I have called infinity. It increases without upward bound and it increases exponentially. Some of you have conducted experiments, for example, over the Pinot data set. And you may have accidentally used the description as sort of one of your inputs, and every single Pinot has a different description, which means every single Pinot corresponds to one dimension where you have a true-false for having that description, right? Which means all of a sudden you have, how many wines are there? There's like 18,000 or something, did I make that up? How many are there? How many Pinots are there? Does anyone know? It's been a long time. Did you say 2,000? Okay. Anyways, 2 to that power is a very large number, right? It's more than the number of people that have drank wine, right? And so what this means is if you turn on our most beloved programming language, the R project for statistical computation, and you ask it to solve some problems related to this, it starts counting to infinity as fast as it can. And it's very, very fast and it doesn't get there, right? So we have to look out for dimensionality tending to infinity. This is an image that I was told to include, and this is what happens when you reduce dimensions. So this is in 3 space. There's 2 people that are looking at each other. And this is in, this is in 3 space, and this is in 2 space. And I think this is supposed to look like they're interested in each other, but I don't know that because I'm a computer science and I don't perceive human connection. Okay. This is one of the all-time famous graphs that someone who's very smart made. This is a blob of what looks like things that are unrelated or have no particular relationship, but if you project them into dimensions, you get my three favorite things: squares, circles, and triangles, right? Look at that. See, there's a triangle there. Over here, there's a square, and there's a circle. Look how cool and fun this is to look at, right? So your job as data scientists is every time someone shows you a blob in 3 space, you're supposed to perceive this immediately, right? I'm sure that's not hard for any of you. See, this only took 38 seconds. Okay, follow-up question. Could you all have made that? Yes. Yes.
Depends on the time limit.
If I assigned it for a homework this week, you could have it by next week, right? You could somehow do this in Plotly and embed it in a GitHub page. And oh, yeah. So I don't know how that was actually made. I think the camera is being manually manipulated, right? So I think you could do it with screen capture. Are you all doing screen capture for any of your other classes? I decided not to make you do it in this one, right? Yeah, screen capture, it's super fun. I'm actually capturing my screen right now.
Wait, actually, yes. We had to make a video for Jed's class.
Did you not do Jed's midterm?
I did just about do it.
Jed won't let me do his midterms. I asked. And he's like, you have to do your job. And I was like, I don't want to. I want to learn Data 503. Oh,
You do a lot.
I make a lot of YouTube videos. Some people say I make too many YouTube videos. Here's something else I've heard. Some people say you're not supposed to make 4-hour-long YouTube videos where there's 30 minutes of silence in the middle. I hear those don't go viral that often, right? So that was shocking to me, right? There exists some optimal number of features. Your data set will not always have exactly these properties, but you should expect there to be things that matter and things that don't. How many of you have listened to every single word I've said this evening? Right, some of them you silently dropped, right? You don't need to consume all of the information. You have some sense that you can pick out the most important bits, right? How many of you have listened to 0 words I have said this evening? Also relatively unlikely, right? The people that didn't show up are the ones doing that. I'm looking at some seats, and I know who's not here, right? And we'll find out if they have optimal performance or not when I check the gradebook after this class, right? But I do have some sense that not showing up to this class is correlated with not reading the rubric before you turn in the midterm, right? Anyways, here's an idea that I didn't have, but someone else had, and I'm taking credit for it. One of my favorite things is plagiarism. Let's cut. Chat clip that, as they say. You can always multiply things together and add them. I usually think of this in terms of encoding image data. So images, here's an image. This image I think of as a lot like a data frame. It is not a 2-dimensional data frame because it additionally has the color dimension. But I can combine that color, and I can give each one of the colors in this image some unique ID. And one of the ways I can do that is each one of the colors in this image is some pixel. That pixel has some brightness in each of red, green, and blue. And each of those brightnesses ranges from 0 to 255. Which means that there are 255 cubed possible unique colors. I can assign each color some number. Now, it is extremely unlikely in this image that many pixels appear because I think this is probably a 400 by 400 image, slightly upscaled, right? Which means there's at most 400 squared unique colors in this image. And probably, even to the most seasoned observer, you don't need close to as many colors as there are pixels to be able to differentiate things. The most famous example of this is, remember a recurring character, Barack Obama, who was referenced earlier? Barack Barack Obama has the famous Hope poster where you can recognize it's Obama and there's like 4 colors on the poster. Do I need to pull it up? Hope poster. There it is. All right, look at this. There's like 2 colors on here. Wait, no, we can count them. Is this a good use of our time?
Yep.
I have never seen that Kamala poster, and that's probably related to something going on in life right now. I don't know how newspapers work. Okay. Wow. If we think really hard, we can figure out why news literacy is so low right now. Don't blame me. I voted for publicly funding journalism. That's not true. It wasn't on the ballot. What did I vote for? Probably something. Enough about politics. Quick. Okay. When you are picking out your dimensions, remember when we were talking about random forests and decision trees, and we introduced this notion of entropy. And we wanted, if we were trying to split up some data set and identify whether things were from some certain region or not, we wanted to ask questions that evenly split up all of the data points we had left, right? We wanted to gain as much information as possible, get as much definition as possible. We get that from having more variance. When we pick out a principal component, we're going to pick maybe the best component first, or maybe we'll get the second best component and it has better second and third components, right? And then we're going to want something that tells us a lot of information we don't already have from the first component. And so I really think on the mile per gallon data set, which I've been thinking a lot about because I almost ran out of gas on the way down here. Fun fact. Reveal. That's why I was thinking about it, right? Did you know you can pump your own gas in Oregon now? That's why I got to class on time, because I didn't have to wait for an attendant. But I think miles per gallon is strongly a function of cylinders cross cylinder size, right? Just some example. And I bet year matters a lot and is totally independent, right? Because I think probably something happened to the gas in those years, something happened with the emissions regulations, all of these things happened, and that is unrelated to engine size. Now, it is possibly the case that as you increase, your engines get smaller or larger. I don't know. Maybe that doesn't matter at all. And maybe an engine of the same size in different years is exactly the same, right? But I bet that there's some underlying thing related to perhaps changing the materials that engines are made out of, changing the materials that cars are made out of that causes them to be lighter or heavier, that is uncorrelated with cylinder volume, right? And so those make sense to me as like those things vary a lot, and there is just as much variance in the data set after I control for engine size when I look at it related to year. And so this is the notice of principal components being orthogonal or uncorrelated. It can be difficult to get perfect uncorrelation, but visually what we're going for here is we want these things to be perpendicular when we put them into some smaller number of dimensions. And so this has these sort of orthogonally directed standard deviations. I think this visualization was really helpful for figuring out what was going on here, because we can often think of these linear combinations as being mathematical operations, but every once in a while, someone sends me an email that says, hey, Calvin, have you ever heard of tactile learners, right? And I loved Play-Doh as a kid because it was delicious. So I was constantly smooshing things, right? We can think of one way of having a linear transform, and so look at this. If we want to construct this from linear transforms, perhaps we can apply a rotation and then a ensmoochment, a smooshing, or perhaps we can apply a stretching and then a rotation. But we can either rotate and squish or squish in some odd dimension, right? Because we have to squish in a dimension relative to the rotation. But if we just do a squish and a rotate, we can get back something that looks an awful lot like our Gaussian vector, right? And we get this sort of notion of independence. And this is what we can have, sort of these original dimensions that maybe we don't care about that much, just show up here as follows. We have a rotation, a scaling. There's not a ton of scaling applied here, right? And then we have the effect on the unit disk. I don't know. Look this up. It's pretty interesting. I love this graphic. Actually, is this graphic a direct link? Look how cool this is. And like, it's just, like, these are just matrices. That's all that's going on here, right? It's based on the golden ratio, apparently. I don't know that. That's cool, right? I'm not going to say you have to hand it to the Germans, but they made a really cool graphic, right? Who loves the island nation of Germany? Okay. And on that note, I was going to start working with our most beloved language, the R project for statistical computation, shortly after this commercial break, which will end at 8 o'clock when I get back from archive with my Mocha. And so my computer doesn't melt, I'm going to turn off all of this nonsense. But I'm not going to pause Oh, that's cute. Uh-oh, the planned dinner is 22 slides from where we're at right now. That's okay. Well, just instead of doing the exercise, I'll just talk. Actually, no, we do have time. I do think we'll have time for the exercise. Okay. There we go. All right, we're not all back yet, so I'm going to start talking. But I'm going to talk about something that doesn't matter. And this is a case I found recently of a naturally occurring linear combination. So I mentioned, like, for some reason I started running. But I went for a run on Saturday, and on Sunday I wasn't still in pain, which I'm used to, right? And so I went for a run again this morning, and I just decided to run twice as far because there's something wrong with me. And then I thought I should do an ultra marathon. So I looked up qualifications for different events, and the one that has been, are we all big Moby Dick fans? My great white whale is the Pikes Peak Marathon, which is impossible. And it's fun because it is a marathon that is also an ultra marathon, because its difficulty is considered so high that even at the 26.2, it's considered harder than marathons. And in order to not cause a lot of problems for search and rescue, which is how they phrase it, you have to post a qualifying or something, right? You have to have some qualification requirements, right? This is like a linear combination, right? You have a minimum distance, and then you have a minimum speed, right? I don't know. I thought that was really cool. This isn't a great one. Let's see. Oh, we can estimate our Pikes Peak Marathon time. Mine is 10 hours. Right? So, I don't know. I thought this was cool. I think maybe the ascent qualifications are more. I guess everyone that does the marathon is weird. Registers running must meet the marathon qualification standards below. Oh, here we go. Here, look at this is interesting, right? So any race over 50K. So if you can run 50K downhill at sea level, and that's 31 miles. They're sure, you'll live, right? And then they're so there's requirements. You have to have a rain-proof jacket with a hood, and a 12-ounce water bottle, and one of these qualifying times. So they give you water every 3 miles, but you can't make it. Yeah. Okay, you're 50K. I mean, my gerbil can run 50K, right? It just takes a while, right? Just kidding. I don't have a gerbil, right? So I think 50K is 31 miles, right? But if you do 20 miles over predominantly unimproved trails. So what did I do when I saw that, of course? I started typing the names of volcanoes followed by race into Google search, right? And I found a 50K run around Mount Rainier that I can't qualify for this year because I'm too slow. Any race with an ITRA point value higher than 2? Well, I don't know what that is, right? Is it the International Trail Running Association? Cool. And then it's like, they'll like give you some freebies here, right? Like, what if you can only run 15 miles, but you do it all at over 12,000 feet, right? And so what is this? This is a linear combination of how much oxygen you're allowed to breathe cross how long you have to be able to run with that little oxygen, right? That's so interesting. So I think at around 12,000 feet, you have 1/3 of the oxygen density you have at sea level, right? And what is that? That is like very, very close to half, right? So they care more about oxygen density than they do about distance, right? And here we have a lower one, right? Oh, here's a vertical thing. So even if you start at sea level, if you run straight up, you still get credit. There's this thing, not the International Trail Running Association, but I think it's called like the Sky Running Association or something. They have an event called the Vertical Kilometer, where you have to do something that is 1 kilometer of elevation gain, which is way less than 4,000 feet, right? Those people that use metric are cowards, right? None of them could get up Pikes Peak, right? Does anyone even know what a kilometer is? Never heard of them. Any Canadians? Oh, you use kilometers? Okay, you're allowed to use kilometers. And then look at this. They don't even make you do a full Ironman triathlon. You only have to do half the Ironman, right? Those things only take like 8 hours to finish. And then you can do a 30K Spartan race, whatever that is. And then after you've done it 5 times, you don't even have to qualify anymore, right? So I've never done any of these things. Yeah. So I'm currently tentatively scheduled to not teach nights next year, which I think means that like if I want to do this, I have to do it in the next 16 months because I cannot sustain the training volume while teaching nights to get ready for one of these things. And I think you have to train for like more than a year to do them, probably. But I don't know. I thought like it's a naturally occurring linear combination. They're like 15 miles at 12,000 feet or 20 miles at 9,000 feet. I was like, oh, it's like there's two vector, right? Okay. Where were we? Machine learning. Okay. We do love those machines that learn. Get learned. And then I was thinking, like, what if I tape a gyroscope to every single one of my joints and, like, train an LLM to talk in my ear when my posture gets bad, right? So I saw this thing that the Pikes Peak Marathon starts in this little town. Sorry, I'll stop talking about this in a minute. It starts in this little town called Manitou Springs. It's really cute. They have a diner with vegan options there, which I know. But and they say the runners finishing look like they've been attacked by a wolverine because people fall so much while they're running downhill, right? Because you have to run downhill for 13 miles after running uphill for 13 miles, right? And there's no oxygen, right? Because you finish at like 6,000 feet above sea level or something crazy, right? So yeah, you look like you get attacked by a wolverine. But I'm like, I can like staple gyroscopes to my hands and have an LLM tell me I'm about to fall before I hit the ground, right? It's perfect.
But like, will you have enough time to react? I feel like then you'll just have a voice in your head being like, "You're about to fall," and you'll fall.
I think knowledge is half the battle, right? The other half the battle is the wolverine, right? I'm much bigger and faster than a wolverine. I suspect I could take one in a pinch if I had to. Not the one that's in the Deadpool film. That one seems much, much harder to win fights against. Okay, right. So speaking of feature vectors, right? If you like Deadpool 3, we don't like the same movies. Okay. So I'm importing Tidyverse and some other stuff. You know what all these are, right? So we've got tidyverse, tidy text. Why do we have tidy text? Of course, it was designed by computational linguistics, right? Or computational linguistics. We've got Caret. Why is that? Because it's a machine learning class, so we have to train models. We've got topic models. Oh, wonder what that is. Previews of coming attractions, right? We've got stop words. Who remembers what stop words are? What's an example of one stop word? Oh, yeah, sorry, no, you raised your hand. Talk. You said the?
Example of stop.
Okay. Does anyone else have an example of a stop word? Do you say Okay. Did you say one? A? Okay, I think you just pronounced A in two different ways, right? My favorite is of, right? I'm pretty sure my thematic library broke at some point, but I'm scared to take it out of the slides. So I just kind of leave it in there and hope the graphs look good. And what do we have? What's this? What? Oh, we're reading from a relative path at a URL. Oh, that's so cool. Oh, that's odd. There seems to be something going on over here. What's that? Oh, we're adding IDs to our columns. I wonder why we're doing that. I wonder if perhaps we're going to do the same thing we do every week, where we take the descriptions and we break them into feature vectors. And we need IDs to do that, because we have to recombine by something, right? Okay, so we have the row ID to column there. And what's this? Is this some new data set? Is this perhaps the data set that is used for modeling project 2? And there it is. I would say in the flesh, but it's actually a machine, so it's there in the machine. Okay. We have done line words many times. Perhaps we should think of line words as impacting the dimensionality of the data set. We add many new dimensions. Each dimension corresponds to some word, or in some case it corresponds to a stem. So not the word itself, right? But acid and acidic both gives to some degree the same idea, right? I don't have stems turned on here, right? But what do? We go through the words, we unzip the description, we make a big column, we populate the column, we zip it back up again, and then every word has a series of signals related to whether it has the presence or absence of the word, right? And why do we do this? Because this is a very good way to differentiate lines. If I say, hey, get together with your 200 closest friends that are all tasting notes and divide up these wines amongst yourselves, that's a relatively good way to differentiate lines. It's a relatively good way to differentiate everything else, right? For example, if I were doing this for Pikes Peak Marathon qualifying events, perhaps I would have a minimum elevation, a minimum distance, a minimum trail difficulty, so there's the unimproved trails versus the any trails, right? And then perhaps I would have a verticality dimension, right? So if you can run uphill 8,000 vertical feet on an unimproved trail at 14,000 feet, then you can do the Pikes Peak Marathon, right? And why would you do that? I have no idea. I assume I will hate it the whole time I'm doing it, but I want to do it anyways. Okay, so when I did this, we ran through line words. You'll see I have structured line words as a function. Are you all getting into writing functions rather than repeating code? I became a really big fan of that actually this term. I have spent a lot of my life copy-pasting random code blocks into a Python interpreter. And when you do that with machine learning, everything breaks instantly because you changed a data frame in some way you forgot about. And then you do that with a machine learning pipeline, so it takes like 35 seconds for you to find out it broke. Or like maybe it just like starts running and you don't realize you did it wrong, right? And so you like get up and you go like microwave your can of black beans, which is the only food I eat, right? And then you come back with your microwave can of black beans and you're like, whoa, the machine learning framework hasn't finished running yet, right? So anyways, I stopped doing that and I started writing functions, and I really like this. There have been so many times this term I've like written a function not expecting to use it again, and then like 20 slides later I was like, oh, I just press a button, or I type 6 characters at my keyboard, right? And I get like the graph back I want or something. It's really quite nice. I should note that we have our manual line words here, by the way. It includes Pinot, Noir, and Gris. Okay. Here are our column headers. Got variety, price, points, and description. we are going to use the PRComp library for principal components analysis. This was ludicrously confusing to me. I have only ever heard of this thing described as PCA, right? So I expect the function to be named PCA, and it's just not. It's called PRComp, right? And there's absolutely nothing wrong with that, but I do want to emphasize I am so used to this thing being called PCA. Like, I don't even know what the R stands for. I'm assuming it's the R in principle. But this completely bamboozled me, and I typed in the wrong thing many times. But anyways, PRComp is just, here, we'll take a look at it. PRComper. It's right here. And if you look up what it does principal components analysis. Why isn't it called that? I don't know. I don't make the rules, right? So here it is. PRComp takes formulas and some other things, right? Wait, is the recording working? Someone sent me an email that said I'm going to attend class remotely, and now I feel bad. Okay. Hello, if you're attending remotely. I can't tell. Wait, no, we can. We can check how many viewers there are. Okay. Yes. See? Look. Look. So, shout out them. You're like just completely built different if you can like look at a monitor for 4 hours listening to me talk. That's something else, right? So I called this thing PRC, and you can tell my brain is in shambles here, right? Because I wanted to call it something that's 3 letters long, because to me PCA is 3 letters long, and I just like didn't know what to do, right? So here we go. Wait, what happened? What did I press? Okay, we're going to PCA the wine. Okay, we took, what is this? Wine-o, which I'm guessing I'm supposed to say vino, but I don't know. Is that maybe Italian? Oh, okay. Oh, it's informal, though. Especially a person without a permanent place of residence who is habitually drunk on wine. That seems mean. Okay. And it's pronounced wino? Wino? Yeah. I feel like we should call this data frame like Winona Ryder or something cool, right? No, we take out the NAs, right? So that's why. Okay. So we have wino, which is our wine words modified data frame. What do? We pull out the variety. We deselect, right? We're going to put that into PRComp, which is the principal component analysis. So we're going to try and reduce the number of dimensions, right? We are going to scale and center. And if we look at this, I'm sure it asks me questions about scaling and centering on here. There you go, scale. And that's just sort of the same pre-processing we've been doing many times. Remember, we first introduced pre-processing with boxcox over KNN, right? And we simply call some method over the data frame before we do anything else with it. And why do we do that? Well, when you start mixing components together, if you have a component that measures things in inches, so for example, the Pikes Peak Marathon has many more inches than feet of verticality, right? But we don't actually care about inches or feet, right? What we want to have is we want to have the level of influence, right? So we kind of want to normalize all these things. So we scale them and we center them to put everything on the same numerical axis. So we don't just have measurements of things with very small units dominating. I always think this is very important when you're comparing like volumetric measures to distance measures, right? Volumes scale on the cube, and so you just end up with very large scale numbers, and frequently you have different values, right? Miles per gallon is like a very odd way of measuring things to me, right? Okay, and so we scale center, and then we're going to look at the summary. And what is the summary? Well, I'm getting back principal components. But these things aren't labeled. They're abstract. They don't necessarily correspond to something intuitive. I mentioned earlier the example of tactile learning. Like There's nothing I can go out and grab about each one of these things. I have to examine them and come to some conclusion about what each of these principal components represents. We notice they have fairly similar, for example, standard deviations, relatively unsurprising given the centering, and also recall we are selecting principal components for high variance, but we do also notice that the variance is monotonically decreasing across the principal components, and there's a big fall off between 9 and 10, right? So perhaps 10 principal components is actually more than we need, right? This 10th one is less than half as useful to us as this one, speaking of it sort of in terms of variance, right? The proportion of the variance is 0.04 versus 0.17, and so on, right? So let's take a look at each of these. We can plot the variance against the principal components. Whatever the first component we find is very, very powerful. It's going to give us a lot of information about our wine. I have to do one slight throwback real quick. I mentioned I didn't think my thematic library was working. That's why when I go like this, the room gets noticeably brighter, right? Because there's a lot of white on that screen. That means one of my libraries broke, and I'm tired of debugging it. But here are our 10 components. Are you all trained to not do this thing where you start one of your axes not at 0? Is that bad? Mm-hmm. I really hate that, right? It looks like this 10th one has no influence at all. And in fact, it is quite small. That's 1.8, right? So it is a quarter as influential, but it is not perhaps 5% as influential, which is how I visually perceive this, right? On the flip side, of course, we have to put this on the slide. But note especially maybe say from 4 to 7 or perhaps from 3 to 7, we have principal components that are relatively similar in influence, right? We have a fairly narrow range there, right? To me, this notion of principal component analysis having sort of, 3 through 7 thing, matches how many adjectives I use sort of in common speech when I'm describing something. I've spoken to some of you about, for example, cars, right? So a red Toyota pickup truck, that's sort of 3 or 4 modifiers depending on how you think of pickup and truck, right? That's about the level of specificity I commonly experience in natural language, right? So I think probably when we have humans in the mix singling these things out, with the principal components, we're looking over like words that people wrote. I think it is unlikely that a wine critic takes a sip of wine and then describes it as having a finish with 7 adjectives, right? I guess I don't know what types of finishes wines have, right? But like, there's probably a relatively narrow range of words that are actually contributing to the differentiation here, right? And to me, I suspect this is what we're perceiving. We're perceiving sort of the level of dimensionality that exists in human minds. This does not necessarily always exist in non-human data sets. Or yes, yeah.
So x-axis is dimensionality, not number of features. Or is it?
I'm suggesting those are the same things, where a feature is a dimension.
Okay. But 2 does not describe a very specific feature because there are 2 features within this.
2 is the second most powerful linear combination of features of the set of 10 linear combinations of features that we have reduced down to having 10 total linear combinations of features. 2 is it is an anonymous feature that is constructed from all of the features in the original data set. Okay. It is it's the return value of a function. This is, well, I guess maybe this image answers your question better than I did verbally. This is principal component 1 versus principal component 2. What's going on here? This is hard to see. I understand that. There's kind of no great way to do this because we're solving this problem by throwing hundreds to thousands of words at it, right? So we plot all of those words. But what's going on here? Well, principal component 1 is a linear combination of the presence or absence predominantly of certain words in a descriptor, right? So principal component 1 has a relatively small absolute value and then negative in direction coefficient on the term flavors. So it is close to 0 and it is on the negative side. Versus principal component 2 it is much more impacted by flavors, but it is also negatively impacted, right? So we have the negative principal component to direction. Let's look at another example. I think that says fruit up here. So fruit is highly positively correlated with the sort of phantom attribute principal component 2, and it is weakly associated with principal component 1. What is principal component 1 capturing really strongly? Points and log price. Principal component 1 is capturing sort of the derived values, measuring the quality of wine, and then principal component 2, capturing the next most important things, is sort of capturing the most important attributes that you would expect in tasting note. One of the things we have seen in this class, this says cherry. We have found cherry to be highly associated with price in many regions. So cherry, despite being a flavor measure, it is highly correlated with log price and points, so it ends up strongly part of principal component 1 in the positive direction, coming in at about 0.3, and very weakly associated with principal component 2. But it is not completely unassociated with principal component 2, because it is unsurprising that when you have cherry and fruit, those things are going to be both in the positive dimension, fruit much more strongly. We also have tannins, which seem relatively unrelated to this sort of quality proxy, but highly correlated with this sort of taste proxy. And then we have tart. Light is pretty odd to me, but then we also see there's some things like finish and oak, which just don't seem to matter that much at all for either of these two principal components. We're not really capturing that thing. Perhaps they'll show up in another principal component. Oh, look, we have one. So here we have 3 and 4. So these are the third and fourth most impactful principal components of the 10, all of which are linear combinations, right? 4 is essentially the finish attribute, right? It is mostly measuring things with finish. There's almost nothing else that's really getting pulled out here. We have slight negative relationships with flavors and tart. And notice flavors and tart have shown up in other principal components. 3 here, this seems to be like the woodiness or the agedness or something. We have a strong inverse on oak, which is almost unrelated to the finish. I don't know anything about wine, but I guess I thought maybe things don't have an oak finish to them, right? So these are highly unrelated. And then we also have things like tannins and so on, right? But really, principal component 4 is capturing things associated with finish. Principal component 3 is capturing things associated with the barrel aging, right? So if we look at this, maybe this is true, and maybe we're not convinced by this. Price matters a lot. Fruitiness matters a lot. Finish matters a lot. And aging matters a lot, right? And we can sort of keep doing this. Here's just a few things we've pulled up. Really jumping out at me, cherry right here. Log price. Coming down here, so we looked at 3 and 4, right? But what's really dominating, for example, principal component 5? Well, principal component 2 was very much the fruit proxy, but it also had a relatively high positive coefficient on tart and on tannin. So I think this is maybe perhaps the notion of, oh, I'm yelling. Have I been yelling the whole time? I got excited. I love linear combinations. I take linear combinations of things all the time. Who loves spreadsheets? Remember when we got to use spreadsheets before we all had to learn scripting? I know, that was a happy time, right? And then I tried to write an expression in a spreadsheet and it didn't work. And I was like, boo, and then I learned about data frames. And now I'm even happier. Okay, so this is some sort of negative flavor proxy, right, which is really strongly associated with fruit. We have a big coefficient on fruit here, right? But we have really strong negative on tannin, on light, and on oak. So I guess this is like some measure of like, I don't know, maybe like citrus fruit versus stone fruit. I don't know. Does anyone eat fruit? Yeah. Yeah. I hear there's people that eat things other than black beans, but I don't trust them, right? This is the anti-tart, right? This is basically just negative tart. Little bit things here on light. PC7 is lightness. And lightness is pretty much the negation of tannins, right? So tannins I always associate them with oversteeped tea, right? So sort of like a drying effect or something. Then we have negative cherry and positive fruit. So when we come up here, right, we have a little bit of cherry, a little bit of fruit, a lot of fruit, a little bit of cherry. We can also have, we can separate the cherry and fruit, right? And that's what PC8 is pulling out. So perhaps non-cherry fruits. We also have maybe, I suggested that perhaps these are like citrus fruits or something. And I think these are all fun to step through here. Like we have the strong negative flavor. It's also negative fruit. What is this positively with? Nothing that's popping up here, right? So I took the top 10 things over here. By the time we're getting to PC9, I'm guessing we're just not seeing on this plot what this is positively associated with, right? And the same is basically true with PC10, which is, points and price unaffiliated, right? So these are things that are expensive and cheap. So they're not a quality proxy like these ones up here, right? So this is perhaps the hidden gems bin in PC10. I would like maybe some like nodding or thumbs upping or verbal confirmation that you understand how I can look at these 10 vectors and like construct a narrative around what they might be referring to. Does that process make sense? It doesn't have to be true. It's just a way of explaining the data you see, right? And you can measure how true it is with more intensive study. So I think when I go to like the cloud computing conferences, they're always talking about like drilling on data sets, where like if I really wanted to figure out if PC5 is measuring citrus, I just extend that data frame and see if lemon and lime are in there, right? And they either are or they aren't, and that answers the question, right? But if I just pull up this data frame quickly in front of my manager, I can be like, hey, look, I don't really know what this is doing, but like here's a possible narrative, here's a way we can understand this. To me, that's one of like the interesting things about data science, that we get to like try and talk about this data and form hypotheses, and you can test them, right? I can't test them here because if I start running PCA on this laptop, it will burst into flames, right? But on my beautiful, majestic desktop with a powerful NVIDIA GPU, I can run this as many times as I want and ask it the most interesting questions in the world, right? And I actually, as advertised, I do have a laptop with an NVIDIA GPU up in my office that I did not get to today because of the rain causing the Oregon drivers to do what Oregon drivers do. You have much better drivers down here in Salem than we have in Portland. Just cherish that. Hold it close. You know, Gail. Yeah. Yes. I don't love driving. Okay, that's not true. What do I love? I love data science. Okay, so here's something I love. I love Plotly. One of my guilty pleasures. I think you all are probably like extremely into ggplots because we basically force you to be. And like ggplots is great. You know it's even better than things that are great? Things with 3 dimensions and interactivity, right? So I love Plotly because I like to click on things and drag them around, right? Like that makes the neurons release the happy chemicals in a way that ggplots does not for me. So I made a Plotly graph, and I thought we would look at this. These things are dimensions. I have claimed they're in dimensions, so I'm going to try and plot them in dimensions. And how am I going to do that? Well, I picked my 4 favorite dimensions, which are up, down, left, right, whatever the third dimension is. Let's see, up, down, left, right, forward, backward, right? Yeah. You got pitch, yaw. I don't know how planes work. And then color. Color is my favorite 4th dimension, right? And really, what should I have done? I should have done a different dimension for red, green, and blue, right? That would have been really cool, right? But instead of doing that, because I care about you so much, because I know you love ggplots, I used a perceptually uniform, or color map, or whatever they are. Are they called color maps? Yeah, okay, so you all know what color maps are. Do I know? Absolutely not, right? And so I just said PC4 is a color. I made a scatter 3D, which was probably a mistake, and then I tried to put some markers in it. Before I press the next arrow, think about what you think this is going to look like. And now think about what you think it is going to look like, given that each of these things are linear combinations of words. And they are heavily dominated by a few words. There's going to be clustering, and there's going to be clustering in different dimensions. Let's take a look at this. Oh, it's gorgeous. Look at that color map. Oh, that's so cool. So this is what really stood out to me, is that I seem to have some of this like dimensional clustering, along certain axes. I didn't really expect the colors to appear in different places, but like it looks like most of the yellows are sort of in this narrow bin here. There seems to be a lot of blues up on the top. I can't really tell how independent these things are from each other. That looks really suspicious, right? All of that sort of same kind of green on that axis. But, you know, when you pull it out and you say, oh, they're just on top of each other. I had fun fiddling around with this for a little bit. I don't really know what to think about it, but it does look like we have brighter colors from, I think of this as the top, and then perhaps darker colors on the bottom. Not really seen the combinations we saw earlier where I have a square in one dimension and a triangle in another dimension, right? But this is one way to visualize the principal components. If I did this again, I wouldn't change a thing. I would just look at this every time. And I think one of the positive outcomes here is I'm not seeing any really strong correlation between the principal components. These two light green lines here are looking a little bit suspicious to me, but when you turn it from another angle, you see there's the darker colors right there. So that's probably just anomalous. I don't know. I thought this was cool and fun. You all know how to make stuff like this, right? This is all good. No thumbs up at all. All right, good for you're putting thumbs down? Okay. First of all, false. The code is right here. Okay. Oh, no. I forgot I can't run things on my computer. It explodes. Never mind. Okay. So I gave the principal components names. I used the same method I demonstrated in front of all of you. Points, or I kind of weakly think of it as quality or perhaps prestige, because it's also really strongly correlated with price, right? So I think French wines tend to be more expensive and more points, but I don't know that that makes them better. Principal component 10 is very interesting, where it's the high positive correlation with points, and then moderate negative correlation with price, right? So points, fruit, a little bit of cherry in both of these, right? Tannins, or oak, right? Because it's the strong negative oak, but positively with tannins. And then finish. And you can just go through your wines and like, wow, this sort of really splits them out, right? So the Pinot Gris, you remember we did the example where there was like, wasn't there like a famous wine critic who had a name, maybe like Roger something?
Yeah.
Roger Federer, probably,
Yep,
right?
That's the one.
Roger Rabbit. Okay. And then, I think Roger didn't like Pinot Gris. And oh, look, it's a Pinot Gris with a low point score. But like these things look pretty highly differentiated to me. Like here's two Pinot Noirs right next to each other. Huge gap on tannins. Huge gap on finish, right? This is really differentiating things, right? None of these wines really look the same. They all have like a bit of a negative on points, but like this one's positive, and that's like very close to zero, right? What this should convince you of, just looking at these six, is like we have looked at a lot of Pinot Noirs that look very similar in a lot of ways, and especially the California and Oregon Pinots all look the same as each other, and they look the same as one of those other regions. I was up in Portland the other day. I think you were there. And I asked the students in Portland if they knew where the Casablanca Valley was, and they didn't know. Right? So then I made them play GeoGuessr. I didn't do that. That would have been funny. I should have made them play GeoGuessr. I'm going to make them play GeoGuessr next week. Yeah. Be like, here's a bottle of wine. You have to guess where it's from. Let's plot these against each other. So, what do we have here? We have fruit, and we have points. And then we have the density at each point. And remember, these fruit and points are not the presence of fruit or points. These are the names of the principal components. And that's why this is relatively continuous. I think it is necessarily discrete, but it might appear as continuous. And so this is how much of the fruitiness you have in each axis and how much of the pointedness. So principal component 1 on the right side and principal component 2 on the left side. I guess maybe I should have ordered them in a different direction. I don't think it matters. And we can break out Chardonnays, Pinot Gris, and Pinot Noir. As sort of we discussed, right? Pinot Gris, highly anomalous with respect to points, right? High peak, much lower, quite negative, right? This thing only ranges down to like negative 2.5, and that looks like negative 1.5 or something, or perhaps negative 1. I think these bars are, I think that peak is at negative 1.25. Whereas the Chard and the Pinot Noir are quite close, though the Pinot Noir has a slightly higher peak. If we look at fruit, not really the same level of differentiation. We do have this sort of secondary peak in the Pinot Gris and the Chardonnay there. So what's going on there? I expect, and I don't know, this would be relatively hard to look into, there's probably some component in this fruit vector, maybe some specific fruit, that critics reliably taste inside, let's see, what is this? This is the Chard and the Gris that's not present in the Noir. So there's probably some white grape or skinless grape. How's white wine made? It's made from any colored grape without the skins on it, right? Did I make that up? Any wines? We really should have had like a 2-week primer at the beginning of the season about like, here's a skin contact grape, and here's like an anaerobic carbonic maceration, or like, I don't know what they're doing in wine these days. Apparently all the wines in Oregon are natural, and they just don't advertise them that way because it's cheaper. So anyways, I'm guessing there's some white wine flavor over here, and then there's probably some red wine flavor over here. Those are the only things that are really driving the differentiation. In fact, maybe that there's just straight up white and red are in the feature vector, right? I don't know. But otherwise, these peaks are relatively similar. Let's look at another one. Pinot Gris has a lot of tannicness, and then Chardonnay has a very small amount of that, right? And then Pinot Noir is skewed off to the top. So we have a high narrow peak on Gris, and then we're skewed high on Noir and skewed low on Chardonnay. Not too surprising. I don't know if I associate tannins with red wines or people talking about tannins with red wines, right? But this matches my understanding. And I do think of Chardonnay as being lighter than Gris, so perhaps if this is a heft measurement. And then finish are pretty much completely on top of each other, right? Finish is not really strongly differentiating the varieties. I made a little function here. If we look at this, what am I looking at here? I am only changing points and fruit, and I'm changing tannin and finish. When I have code blocks this big that are this similar, I should break them out into a function, and I call them thing 1 and thing 2 after Dr. Seuss. I do not like green eggs and ham. I do not like them, Sam I am. I do not like them here or there. I do not like them anywhere. And once I have written this function, look how easy this is to see. Look, we can do fruit and finish right next to each other. And we've already talked about fruit and finish, so we can decompose this. Do you have the technological maturity to figure out what is driving these little peaks here? I argue yes, right? You can look at the things that are making the feature vector. You can look at things that can cause you to get to -2. There's only going to be a few things with really strong coefficients. And then you can look at them for Chardonnay, Pinot Gris, and Pinot Noir, and sort of drill and find out what is causing those peaks, right? I am suggesting to you it is something associated with white wineness. I don't know what it is. I think we can figure it out. We are going to add words. And at this point in time, I am going to have our favorite type of audience participation, which is mandatory audience participation. And I'm not going to press the next arrow on my screen, which really isn't a very big thing to threaten you with, because you have all of the slides and the Quarto markdown, even though I tried to hide it from you, right? I previously provided 500 as a parameter to wine words. That 500 did something. It impacted the number of words we had in some way. Now I am providing the parameter 100, and I claim that this is going to increase the number of words that I consider in my data frame. Why is that? You have to know this one, and you can figure it out by looking at the code. Or sorry, did you?
Is it based on proportion proportion? Like there's just more words, like if you have more words, it'll be a smaller proportion chosen?
It is not based on a ratio. We're going to do, ready?
Is it dropping the worst words instead of selecting for the best?
It is not changing the goodness or the badness of the words. Ryan. Sammy, what do you have?
I don't have anything to say.
Sammy was going to say he's checking if words appear 100 times rather than 500 times.
Why did you not say that, Sammy? That's correct. Okay.
I didn't say that.
It doesn't matter why you said it. Oh my gosh, just take credit, right? Like, most of my accomplishments in life happened by standing next to someone that accidentally accomplished something and dropped it, and I picked it up before they got to it, right? That's how I got my doctorate. Is that true? That's kind of true. There was this grad student in my group named Ray Zhang, who was like someone who earned a PhD, right? We don't all earn them, right? Some of us just screw around for 6 years and then our advisor tries to get us to leave, right? Anyways, Ray like published all this stuff and needed a second author. So like, I have like 80 of my 200 citations are from this paper that Ray needed someone to run one reproducibility result on, which I did incorrectly, and then Ray had to go back and finish it, but it was too late. My name was on the paper. You can look at me on Google Scholar. My most cited paper is this paper with Ray. And so that's how I became a professor. Does that explain anything? Don't think about it too much, right? Just, stay in the zone. This is words must appear more than 500 times. It is specifically words. We're not doing stems, right? To me, I am not sure how to associate like the stemminess, right? Because when we change from words to stems, we reduce the overall number of words, right? But by reducing the overall number of words, we increase the frequency of words in general, right? So we are more likely for a stem to occur 500 times than we are for an individual word. I do not know the distribution of words and stems in wine descriptions. I have no idea whether changing between stems or not increases or decreases the number of features, right? Couldn't even guess. Don't even know if it's related to the cutoff points. But anyways, they appear at least 100 times in descriptions, and they are not stems. Thank you, Sammy. So, when we do this, remember how much we love when these graphs start at non-zero? That is way higher, right? Our principal component 1 last time had a 1.8 variance. Relatively narrow, right? So those ones correspond to the presence or absence of some word, right? We're going to multiply them by some coefficient, but all of the coefficients we looked at were basically in between -1 and +1, right? Gotta take another sip. My voice is in shambles. I really like, you all like stromboli? I think it's like a calzone with mustard in it or something. I don't know. I'm not a chef or a cook. I don't even really eat. But every time I say like my brain is scrambled, I always want to say it's scramboli because I like the bully ending, right? And scram and strom are like pretty close together. So anyways, I'm scrambolied right now. Woo! All of these principal components are like way higher variance than the other ones. I wonder if that's because we have way more words. Do we have 5 times as many words because we changed from 100 to 500? Probably not, right? I suspect that if there are few words that occur 500 times, probably more than twice as many words occur 250 times, because there'll be relatively few words that occur many times, right? And words that only occur 100 times, there's probably going to be like several times as many. Do I know how many? No, but I could figure it out, right? Easy enough to add that up. We still center and scale, as we're wont to do. Something interesting I see here, this is a different shape. Before we sort of had like the weak sigmoid where we had a very high PC1, a relatively high PC2, then we had a relatively flat range, and then we fell off. These are staying steady. This would suggest to me I could go up to 20 principal components. That doesn't seem bad at all. Why would I go up to 20 principal components? Well, I'd get higher predictive power, but I'd have lower explainability, right? So that's what I'm training off. really maybe I just want to grab these top 5 and think of this in terms of, I really want to use 5 adjectives to describe everything. If I have 5 adjectives to describe things, that means that I can have yes or no for each of those adjectives, which means I can have 2 to the 5th ways to describe things, which is 32 different bins just using the 2 principal components. And that's if I only have true false values in each of those principal components. How many times am I going to need to differentiate more than 32 wines in front of someone? Right? Seems like 5 of these is plenty. I'm guessing I can usually get away with 4 of them. I think I'm very rarely evaluating more than 10 wines at a time. Right? I don't do wine tasting, but I do coffee cuppings semi-regularly. We usually get 8 coffees, right? Which means you can completely differentiate them with 3 principal components, right? That's plenty. Here's the principal components we're working with. I suggested last time when we had the oak attribute that was perhaps associated with aging. Doesn't look like we get months very often because we didn't see month last time, but months is dominating principal component 1, right? Look at that. And we still have points and price very strong, right? So that's coming in. French is coming in. Can I hear it for France? Oh, come on. I think they only work 4 days a week now. They have never elected Marine Le Pen. Take notes, Americans. We have a much stronger month oak association on principal component 2. And we also have France. Oh, did you all get to hear Miss Universe? Or no, it was probably Miss France at Miss Universe, right? Saying France. Oh, beautiful. I wish I could speak like that. Look it up when you're older.
I know, it's in the school. It's in the school.
France! Like, I don't know, like, yeah, it's fun. It's fun. We should all speak with such confidence, right? Nothing but respect for my Miss Universe. I walked by the hotel that Miss Universe was in once for some reason. I don't know. Seemed fun. They all seem to be having a good time. And then there's Valley. This is, of course, associated with the Willamette Valley. Shout out us. Go up to enough words, boom, you get a Willamette Valley principal component, right? And that's because we're awesome, right? I gave a talk somewhere to the Salem City Club, right? They're like, we want someone to come explain AI to us, and High-End's busy. I was like, put me in, right? Because I don't know what AI is. That's not true. Don't write that down. I know what AI is. It stands for artificial intelligence. I was giving him a talk, and so I of course, stole slides from Jameson, because that's how I seem like I know about AI. But he has this thing where he introduces text prediction, and the first word is Willamette, and then you have to guess what comes after it. And I said River Valley, and got in so much trouble for not saying university, right? Because apparently I'm supposed to associate Willamette with a university and not a river valley. But what about the American Viticultural Area, right? The AVA, right? The Willamette Valley AVA. Look, it's a principal component 4. I am just doing computational linguistics over the class I'm taking. It's not my fault I didn't think of Willamette University. And now we have something called Willamette College, right? So that's 2 institutions of higher learning in 1. Anyways, I call these price French oak, also French oak. The French, do they really need 2 principal components? Of course they do, because we get our own, so we don't care what happens as long as we get our own feature vector. I love the Willamette Valley. The Willamette is a beautiful river. It goes into the Columbia, which is named after a sportswear company. Okay, so I called these French oak and French broke, which I think is hilarious. Look at this. So one of them is positively correlated with price, one of them is negatively correlated with price. Those are such small coefficients, right? But you know, this one's positively correlated with points and negatively correlated with points, so that's a pretty big difference. So I think this is good and bad French oak wines. So I called it French broke, which I think is funny. I could speak, for example, in broken French, right? I could say, han, oui, omelette du fromage, right? And that would be fun, right? We'd all have fun if I did that, right? That's my French impersonation. I could order an Americano. I couldn't. I can't even do that in jest. Okay, so we've got the Willamette Valley, which has predominantly grows these 3 varietals, so we just stack them all up right there. That's pretty cool. We have a big point spread, of course, Pinot Gris scoring lower than Chard, and then Pinot Noir scoring higher, because for some reason, red wines are just considered better, as far as I can tell. Again, I don't know anything about wine. I do know how to wine, but that's a different spelling. Okay. I know what you're all thinking. You're thinking, I love naive bays, right? Remember Bay Caught Me Naive-in? Remember that one? That was one of the hits in this class, right? And we measure how naive Bay caught us being with the kappa value, right? Cohen's kappa value, right? So we do a quick train-a-rooney here. This is the train over the principal components. So we have 10 principal components over words that occur more than 100 times. We're trying to predict the variety in between Chardonnay, Pinot Gris, and Pinot Noir. Do I have to say Pinot every time? It seems like I could just say Gris and Noir. There seems to be zero information carried in the Pinot. So if I were to train a neural network to recognize patterns in my speech, it would apply a 0 weight to me saying Pinot, right? You got to think about these things. Okay. Am I making sense tonight? I feel kind of woozy, but I'm having a great time. I was reading the survey that like 4 of you filled out, and I was like, dang, I'm awesome. So I decided to be more like myself. And so all of you that didn't fill it out, you're going to regret that. Okay. I am not accustomed to the R project for statistical computation way of returning values where you return these sort of big textual descriptions. That sketches me out. I like it when my functions return numbers. Ideally, they would be integers. I'm willing to accept a floating point number under duress. But really, I think you should just probably multiply that kappa value by 2 to the 32nd and let me figure it out, right? And so for the sake of Model 1, I went in and figured out ways to just get the kappa value directly out of this confusion matrix. And it didn't take that long at all. But I do want to ask you all something. I don't know what the difference between $ overall and including something in brackets means. What does that correspond to in the data frame? Because I really think both of those should just look up a row. And I should have a series of rows nested together. So $ is columns and then brackets is rows?
Depending on, it goes, you can technically do rows and columns inside of a bracket.
Mm-hmm.
Depends on how you want to do it, but because there is nothing after it, it automatically assumes you have a row.
If I put bracket, so if I put this bracket here and I said overall comma kappa, would that give me the same value?
It would have to be kappa,
Kappa comma overall?
just rows, columns.
Okay, and then the one follow-up question is, do you all have from your other classes in R like a style guide? Is there like a preferred way to write something like this? Like, should I use the $ or should I use the bracket notation?
Isn't that because the confusion matrix is a data frame of a handful of data frames, not just one two-dimensional?
I believe so.
It is definitely a nested data frame.
So
But
you're getting the overall data frame, and you're pulling the kappa value of overall.
This syntax makes the most sense to me because it's like, okay, you're finding your column and then you're going to where you're finding kappa versus when you do the.
I'm going to say my takeaway is this makes sense to all of you. Okay, because this makes perfect sense to me. This is exactly how I think of it. So like if this works for you, I'm going to keep doing this. I don't mostly like how the $ look, but like I can get over that. I'm a grown-up, right? For some value of grown-up. Anyways, look at this. Look at this kappa value. Look how high that is. That's over 0.6. Let's hold on. Let's see how good 0.6 is. We go to the teaching site. We go to machine learning. Wait, why did I call this ML instead of machine learning? I bet it doesn't fit on one line. Let's look at the scoreboard. Oh my gosh. Only group 5, whoever that is, shout out group 5, right? Oh no, here we can sort by. Look at this. It is anomalous to get as high as 0.6, and some of you are quite close, right? Also, this information is leaking a little bit. The different number of digits here correspond to different methods. So if you're very, very sneaky, you can derive a feature vector from this and figure out who people are, but don't do that. Anyways, it's like it's hard to get a 0.6, right? Like you all worked on the modeling project. It was miserable, right? We all hated it. I had a great time. I was like, oh, look, wine. Woo! Yeah, I love the Willamette Valley. It's my favorite river valley. And so, like, we didn't use our brains at all. Like there was zero thought put into this. We just downloaded the principal component thing, executable, just ran it in R, and boom, 0.61. That's incredible. We did use naive Bayes. Naive Bayes, well suited to these cases where we have true-false features, right? So to me, it made sense to have that. Should we have done KNN? I don't know. I did naive Bayes. Time for dinner. I think it's almost 7:30. Yep. I have got to figure out what Hendrick and Jameson do when they teach this stuff, right? There's 30 slides left. And one of them's an exercise that was supposed to be the entire second half of class. But I feel like we're learning, right? Yes. You have to say that. You know how long this thing is?
Terrible.
Absolutely terrible.
Would it be shorter if it was a process?
Wait, no. Oh, I went to the last thing again. How'd I do that? Does anyone know how this website works? Okay. I think I need to make you think for 30 minutes. Yeah, no, it's fine. It's fine. Like we had fun tonight, right?
Yep.
So you're all at full power. Load the bank data, the churn data.
Yep.
You should have loaded the bank data if you're following along in the Quarto Markdown, right? It was the new data I introduced. It's for Model 2. Run PCA over it. You have the examples of how to run PCA. Remember, it's PR comp, it's not PCA. That's what confused me every time, right? Make the scree plot and choose a number of factors. Now, versus descriptions, right? Descriptions are written by humans, and humans think in collections of 2 to 5 adjectives, right? That's not necessarily going to occur in the bank churn data, but it could because some human prepared the bank churn data, right? And so they made some decisions about what to write down, right? So pick a number of factors, make one of the scree plots. Remember, the scree plot thing was very easy. It just was that line chart. And it was annoying it didn't start from 0, but it was a built-in, so it was nice to use, right? I demonstrated to you the process of looking at some of the linear combinations and deciding how to describe them, right? Go through that process, try and give these principal components a name, and then plot or don't plot using the density plot, but I gave you the C2. Remember that, where you see two things? And it just stacks them on top of each other. So you should just be able to call that function and make some minimal edits to it in order to get a PCA. And the real reason we have to do this is because my voice is dying. So work on this for a half hour, and then we'll come back and I'll yell for another half hour, okay? What's up, YouTube? Oh, hey, people are talking. Hey, what's up? Yeah, Nate Silver. I don't like 538 though. Wait, he's no longer associated? Watch Princess Mononoke? That sounds good.
Yes.
Yeah.
That one's amazing.
Well, I'm just going to watch all of them now, right? Like,
Yes, you
Yeah.
should.
yeah. The only thing I have to
Tell
do...
me you've seen Help in the Castle.
No! No, I've only seen Nausicaa.
Which, I mean, fantastic start.
Yeah.
You should watch Mononoke.
Well, so I was waiting to see it in theater.
Yeah.
So I've been trying to see them for years, but I wanted to see it in a theater.
I just drank
You should watch Portorosa. That's the line I'd rather do. The Atlas is great.
That's just, I say that like every
my
day.
life. I've like been through a lot.
Wait, why am I showing this? I don't want to show YouTube yet. Okay, YouTube friends, concurrent viewers, hello. I'm going to turn off screen share to not melt my computer. We'll be back in like 30 minutes, and hit us up in Discord if you need anything, okay?
I mean, okay, it's just a
Where's the...
but like, it's also easy because I don't have to make people to make decisions. So I can just work on it whenever I can work on
A
it.
little like
All right. 22 minutes left. Time to listen to me talk. Welcome back. I don't have any planned funny jokes, so everything will be extemporaneous and hopefully fun. Some of you looked ahead, which is a good use of your time. You do not have to use fast dummies, but it's nice to use fast dummies. Why is it nice to use fast dummies? I talked to a few of you. You were all looking at, for example, up here we were talking about education. Graduate, postgraduate, doctoral, college, high school. Those are features, right? It is unclear necessarily what the ranking between them is. I would, if I wanted to include that as a feature, I would probably try and get to some like years of schooling proxy, right? Not super easy to get that. And so perhaps it just makes sense to throw in a dummy value for each of those. When I was doing this on my own, what I did is I just found the, I think, rarest attribute in each and then threw out everything else. And so there's different ways to do that. So anyways, this is the return of fast dummies. Someone said fast like my Lambo. In the words of Jay-Z, I can't even say the name of that song. Never mind. Okay. Okay. So here's the principal components. There's like an alarming number of words that I can't say. Right? There's like 2 of them. Right? Aren't there only 2 words I can't say? I don't. Maybe there's more.
I feel like there's definitely more.
You think there's like 4?
I think it's at least double digits.
You think it's at least double digits?
Yeah.
All right. But I think I've successfully not said any of them.
True.
Right? I like to live dangerously, speaking out loud in front of large groups. What do? We fast dummied. And actually, I'm not fast dummying in here at all, right? I'm just PR comping. Right? We mutate churn into yes, and then we dummy call. Okay, so we're just running dummy calls naively. Okay. Here's the PR bank. This is the public relations bank. This is the bank that has good public relations. Just kidding. No, that stands for principal component. Why does PR stand for principal component? Well, because we had to call the function something. It's called PR comp in this programming language, right? So we're just going to stick with that. This is the scree plot, which it appears by default to run over 10 such principal components. What am I looking at when I see this? Well, to me, the thing that jumps out is I have one really, really good feature. And I'm guessing that's the how much money you have feature, right? Somehow we're figuring out how much money you have. I don't know a ton about the banking industry, but I think when you're running a bank, you want people with lots of money to use your bank, right? That's my understanding. Very close to twice as much variance. What does that variance correspond to? Differentiation, predictive power. If someone walks into my bank and I know relatively few things about them and I want to predict if they're going to churn or not, and do I know what churn means? Doesn't affect me at all. I get the mathematical problem and I think about numbers all day and then I tell my manager the answer, right? I do not care about the human impact, and I especially don't do that when I might be deciding who gets loans to buy their first home, right? I don't want to think about that stuff, right? So I'm just predicting churn based on numbers that come into me on a .xls spreadsheet, because of course it's on a .xls spreadsheet. So what do? I download a command line tool that turns it into from a .xls to a .rds, and then I open the R to Python bridge and still working in a pandas data frame, because that's who I am as a person, and I will not apologize for who I am unless I say one of the 20 banned words, in which case I will apologize profusely and probably also walk into the sea. So what we have here is we have one very, very important principal component, which I'm guessing that's the have money component. What's this? I'm guessing this is the know people that have money component. And then I think everything else matters roughly the same amount. Now there is a high slope here between 5 and 6. And I'm guessing that corresponds to a real falling off of interest, probably at the end of the different proxies for measuring how much money someone has. Now, there's a variety of proxies for how much money you have. I think, in general, in the United States, if you are older, you tend to have more money. I think in aggregate, people save money over the course of their lifetime, even if you control for everything else. I have suggested to a few of you that some of these are probably proxies for birth zip code, which I know is a strong predictor of lifetime earning potential. Maybe some of these are proxies for educational attainment, but educational attainment is, increasingly weakly predictive of income. What you really want to do is drop out of high school and learn to weld underwater and also survive. So here are the different principal components. We're looking at the 4 because this is before the high fall off. We'll see that these are broken out in some way into the dummy variables, and so we can give each of these names. Let's just go through this and use our sort of method we've been using. So principal component 1 strongly differentiates genders. If I didn't know anything about gender studies, that would be alarming to me, but I believe I live under something that bell hooks called white supremacist, cis hetero-capitalist patriarchy, which I understand that to cause strong differentiation in salaries for people that are perceived as men and people that are perceived as women. It is unsurprising to me, and it is unfortunate, I think, that it looks strongly like you have more money if you have a certain gender marker. So that is one of the things I perceive here, and this seems to correspond to credit limit. I don't really know what openness to buy is, and I don't necessarily know how you measure it, right? But we have 3 big bins here: credit limit, openness to buy, and masculinity, right? We can go on and look at the next one, and what are the things we have? We still have masculinity, but now it is anti-correlated from the previous one. So we had card category blue. What is this? I'm guessing this is an information leak. Someone administered these cards, and someone used their categories for something. I think there's something called, for example, AMX Blue, which is maybe like a more prestigious card. I'm guessing that's what's going on here. I'm assuming blue is not necessarily the most prestigious because as we're trying to predict churn, we have negative and then positive. So this is predicting something else. It is probably a measure, for example, of the stability of the bank because it is negatively correlated with the total transactions. So maybe people that spend a lot infrequently end up with card category blue. And those are really the strongest things we see here. We have mask, blue, and then we have a bunch of negatives here, right? So relatively weak. The thing that really jumps out to me about PC3 is it is anti-correlated with age. These are the youths. How many of you have met some youths, right? Bunch of rapscallions they are, right? And people that are youths also have fewer months on the book because they have fewer months in life. I have been attending the School of Hard Knocks for exactly how long I've been alive, right? So that's how many months I have on the book. It is exactly correlated with my age, right? The positive correlation here is the total transaction count, right? So if you have little age and big numbers of transactions, then you're in some kind of bin. This again suggests we have pretty strong gender separation across all of these categories, right? And then, some weak interest in card category blue. The last one is the negation of the previous one. So we have high positives on age and months on book, but we still have the transaction amount. So what's this splitting up? In my view, we're looking at old and young, or I don't know, do you want to say old and young? We have people distributed by number of years on Earth, but that have similar numbers of transactions, right? So these are people that move lots of transactions through some bank, regardless of their age, but we consider the ages separately when we're looking for high predictive power, right? So this is Hendrick's solution. Hendrick works for Umpqua, is that how you say it? Actual existing bank, right? So Hendrick plays with giant piles of money all day, and I believe might hire people, and also likes Python. I don't make the rules. I really, really looked for a Blue Man Group joke in here. I could not find one. I looked so hard. Then when I couldn't do Blue Man Group, I was like, can I get like Blue Mango or something like that? I couldn't get anything. But anyways, we have buy credit. Lots of credit, lots of willingness to buy. We have Blue Man. We have high transaction counts, and then we have high age. Okay? So we split those up, and we see that, those peaks are pretty close to each other. But we have a high peak for churn with Blue Man, and then a high transaction count is also associated with not churning, right? Because we have positive on that side of the screen, and so we have a false churn value is associated with a higher transaction account. The same thing is true with age. I made the claim that old people have money, and I am suggesting this as evidence, which means that when my parents take me out to dinner, they should pay, right? That's the takeaway here, right? And they should also help me buy a home. Okay, they didn't like that one. I had some family out here for Christmas, and I was like, you should give me $200,000 as a down payment for a home. Anyways, I recommend trying that one. It was unsuccessful. Okay, bag of words is like super cool. We've been doing bag of words this whole time. What is a bag of words? So say you have a description of wine, and it contains the term tannin, and it contains the term fresh. Do you really care if that has not in front of it? Not really. Doesn't seem to matter. Big linguistics told me that negations don't exist, right? They're very Hegelian in that sense, right? We all remember Hegel talking about the negation of the negation, right? Do we all remember this? All been reading your Hegel? I'll assign some Hegel for next week. And so we've been doing bag of words, but especially post 20, was it 15? When did the Transformers paper come out? Does anyone know? Any LLM fans? Anyways, at some point in time, someone noticed that there's more to life than what words you say. And there's these ideas of topics. We were speaking about genres in the back. There's these sort of thematic, I don't know. There's ideas. There's ideas that exist at a higher level than words. And oftentimes when we start reducing our dimensions, we end up getting these things that look a lot like themes. And so here's my source. I gave the example of, what was the example? Right, so my favorite word, that's not true, but for the sake of this argument, my favorite word is duck, right? And ducks could be associated with, for example, party games, because my favorite game is Duck, Duck, Goose. They can also be associated with people that are huge nerds, because my favorite web browser could be DuckDuckGo. And they could also be associated with people with bourgeois ruling class tastes that like duck fat fries, right? And so duck can be associated with all of these things. But with the benefit of just a few other words, duck can be associated with each of these concepts. So if I have duck and go, I know I have a huge nerd. If I have duck and goose, I might be outside or I might be at a party. But maybe if I have duck and birthday, then I know I'm at a party, right? And I know that I'm not talking about my age or an ID, for example, and so on. So there are these intermediates, right? So for example, in soccer, you famously have dunks and rebounds, and in basketball, you famously have free kicks, and at the NBA. The NBA, or as I like to call it, the MNBA. Real ones know. Okay, and so when you have some series of words, you may be able to associate it with some topic or some theme, right? And we do this in two ways. You can just do this with principal components analysis and just use generalized techniques to try and get it. Or you can use this LDA technique. And so now we're going to introduce this LDA technique for, actually we're probably not going to introduce it at all because we have 8 minutes left. Let's see how fast I can talk. Okay. Okay. Behind the curtain is someone that's going to press this button a bunch of times. Wait, no, I don't have to do that. Okay. Let's look at the topics. Okay. So what's going on here? I want to introduce these two levers. We've been thinking a lot about words, and I need to introduce two other ideas, and they are topics and documents. A document is a collection of words that corresponds to some measurement. It is the description of the wine. The topic is the emergent phenomenon we have found, perhaps with principal component analysis, but perhaps with something else, right? It is an idea that is related to certain words. Different words are related to different topics. Free kick is related to soccer and not basketball, right? So, when we are looking at this latent, I don't even know how to say the word. Is it like Dirichlet allocation? What we're doing is we have a probability of a word being affiliated with a topic. So when I say duck, how likely is it correlated with fries versus how likely is it correlated with a party versus how likely is it correlated with a browser? And then separately, when I have some sentence that contains, you all know my favorite word is duck. Wait, dodgeball. Dodge, dip, duck.
Dodge.
Exactly. That's what I was going for. So I have some document, such as the complete text of the script of the film Dodgeball, which is exactly as artistic as James Cameron's Alien 2, right? And there is some probability that that textual document is correlated with some topic. And in the case of the film Dodgeball, it is related to no topics at all, right? And if you want to learn more about this, you should open this page. Now, what we can do is we can break out from the wine different topics and different words. So we have phantom topics, which are given numbers. We have terms that are affiliated with the topics. And given the description of a city for some wine, it is maybe associated with some high-level abstract idea of what a wine could be. And I always think with acid, I perceive acid tastes in two ways. There's the vinegary taste and there's the citrus taste, right? So these are natural things to be associated with acidity. So there's the vinegary topic and there's the citrusy topic, and both of them have some acidity relationship. And I suspect topic 1 is probably the more citrusy one because it is highly crisp, right? So these are the word topic probabilities. We can relate topics. So if we fix the topic to 1, it has some relationship with flavors and fruit. This is corresponding quite closely to the principal component analysis. And, ooh, that's small. Can I make that bigger? Why is it small? Okay. Not to worry, I have a plan. When we break out our topics, we are getting topics that are quite similar to the notion of the principal component analysis we saw. Remember flavors, fruit. Here's the negation. This is different than principal component analysis, right? Because it is looking for a topic rather than just a principal component. Fruit's dominating everything for that reason, except cherry. We can plot these. We can do the same thing with the different documents, so that a document is a description. This description of the first wine has some gamma value, which is a document to topic probability for each of the principal components, right? And they're quite similar here all. And then we can predict variety from each of these. And I think, I don't know, that's kind of all I want to say about this. You can look at LDA. I have never seen anyone use LDA, but it's pretty cool. The example we were going to use is Associated Press. I read the news from time to time, not voluntarily. And my perception is some news is about things Congress is doing, and some news is about things that CEOs are causing to happen. So, for example, there was a bunch of stories about retail crime for a while that was caused by a sort of a consortium of CEOs calling up their PR agents and causing things to show up in the news. And I detected that sort of cluster by reading it, right? And the way I discovered that cluster, right, is there were certain recurring words in all of these phrases, right? So if you look at the Associated Press, you can find topics. The usefulness of thinking about this in terms of the Associated Press is I think we know the difference between a sports story and a politics story. Those are the topics. And when we see bat, we expect that to be a sports story because we're expecting it to refer to a baseball bat. And when we see president, we expect it to be referring to a politics story. That's sort of what's going on here. If you just run the topic analysis, we have, what is this? Percent new million year. Those are economic stories. Those are about the stock market. And over here we have people, police to government. This data was taken during the fall of the Berlin Wall and I guess it wasn't called the Balkanization at the time. whatever we called balkanizations before balkanization that happened to the Soviet Union, right? So all of this stuff is about the collapse of the Eastern Bloc, right? And so we see things like United States, New Year's military, state, so on. And those are topics. And you'll notice that the most exciting topic is communist. Okay, on that note, do not report me to the authorities. I can neither confirm nor deny I'm a communist. I am looking forward to seeing you next week to talk about k-means and hierarchical clustering, which are the forms of optimization theory that I use in my research. So that's very exciting for me. Get enough sleep and be friendly and cheerful for the rest of your classes now that you've had spring break. Jacob, you should be at full power right now.
Yeah.
We just gave you 9 days off.
Yeah, but I was on the other side of the world, so I'm very tired.
No, that should be better. I also want to be on the other side of the world. You got to be there.
Yeah.
Where'd you go?
Malaysia.
Oh, okay.
Yeah.
You fly over the Pacific there, right?
Yeah.
Yeah.
Direct flight from Seattle to Singapore.
Oh, through Singapore. Okay.
Yeah.
Are the signs in the Singapore airport in English?
Yes.